Hey, this is Andrew Brown from Exam Pro, and welcome to my AZ900 course, also known as the Azure Fundamentals Certification for the Azure platform. So if you're new to cloud and you don't know anything and you want to get into it, this is the course for you, because we're going to show you how to set up your account, look over the core services, and more. And as always, I love to hear your feedback. So if you're on Twitter or LinkedIn, definitely tell me how the course is. And if you do pass, be sure to hashtag Azure Certified on Twitter, and I'll definitely reach out to you. I hope you pass, and I'll see you soon. Hey, this is Andrew Brown from Exam Pro, and we are looking at what is the AZ900. So the Azure Fundamentals is the entry-level cloud certification for Microsoft Azure. The certification is generally referred to by its course code, which is the AZ900. The AZ900 is about knowing the Azure core services, the fundamentals of cloud computing, and having a bit of hands-on experience working with the Azure portal. And if you look in the top right corner, that is what the certification badge looks like once you earned it for the Azure Fundamentals. And then just talking about certifications in general for Azure, if you want to have a roadmap as to what you would do after this certification, Azure breaks up their certifications, their role-based certifications, as fundamental, associate, expert, and specialty. So in the fundamentals, we have the AZ900. For the associate, we have the administrator, the developer, the AI engineer, the data scientist, the data engineer. If you notice, for data engineer, you're going to see there's two course codes under it, DP200, DP201, because some certifications require you to pass two different exams. So if you want to become a data engineer, you have to pass those two exams. The expert level, we still have the security in associate, but the expert level, we have the solution architect expert, where you have two exams you have to pass. Then there's the DevOps engineer expert. And then for specialties, we have Azure for SAP workloads and IoT developer. So these are all the Azure certifications that are role-based. Azure or Microsoft used to have everything that was very service or technology specific, but things have changed to roles, which makes things a lot easier for people that are hiring, because people that are hiring will look and say, oh, you have the data engineer certification. You must know how to do data engineering. So that is really simplifying things. You can take any of these in any order that you like. So if you want to go to the expert level right away, you absolutely can, but it's not generally recommended. You should start with fundamentals, associate, go to expert, but whatever you think is best for you, that's what you have to decide. So who is the AZ900 for? Well, it's commonly obtained by sales and management to help inform VPs or CEOs reasons for their company to utilize Microsoft Azure. And among developers, it's to show they have familiar knowledge with cloud concepts. So anyone that's like, if you've had a programming background, but you just don't have cloud experience, it's just a great way to tack on the cloud skill there. And the AZ900 focuses on building security and business-centric concepts, which makes sense because if it's designed for sales and management, it's going to be things that are going to help them convince to adopt it, such as like using the TCO calculator and informing decisions like that, like knowing SLAs and things like that to drive business decisions. So what value does the AZ900 hold? Well, if you're a developer, it's not going to be that useful on your resume. People aren't going to be trying to hire you just because you have it. You're really going to have to move on to the associate or expert track. But that doesn't mean you shouldn't get this one. If you are a developer and you already have cloud knowledge in another cloud provider, say you have AWS skills, you already have an associate level, and you just want to show that you can work cross-cloud, grabbing this certification just shows that, oh yeah, okay, I poked around the Azure portal, so you'll have that transferable knowledge. So that would be a good case to get it as a developer. Or if you don't have any cloud certifications and you want to make Azure the cloud provider you want to use, then that makes sense to go get. The main reason I tell people always to get a fundamental certification is because it helps them build confidence before you take a harder certification. And it also gets you familiar with the exam experience, whether you do it in person or online, because that can be extremely stressful. Okay, so now you're convinced that you want to go get the AZ900. So you're going to be asking me, well, how much time do I have to put in to gain this certification? Well, if you're a developer, say, a junior to mid developer, and you've been working in the industry for a few years, but you don't have cloud experience, I'm going to say that you're going to have to spend about 8 hours of study. If you're a bootcamp grad, so you don't really have any real world industry experience, but you want to try to tack on cloud as early as possible to help your resume and stand amongst the crowd, you're probably going to be spending 15 hours of study. If you are in sales or management, so you just do not have a technical background, but you're trying to understand why you should adopt Azure or cloud for your business, you're looking at 20 hours of study. And the way I recommend it is you want to put 1 to 3 hours a day for 7 days. And I mean every single day. You don't want to spread this stuff out. Now, next question is, where do you take this exam? And the way it works with most cloud service providers is they are partnered with a company that is also partnered with a bunch of test centers around the world. And the one that Azure is partnered with is called Pearson VUE. But the great thing about Pearson VUE is that you can either go in person to a test center, so you use their Pearson VUE website and it would tell you test centers nearby, or you can take it from the convenience of your own home. So if you have a web camera and you have a very sparse room so that you don't have a bunch of things in the background and they can trust that you're in a secure location, they'll let you take it from your home office. And that's what we call a proctored exam. And the reason we call that a proctored exam is because a proctor is a supervisor or person who monitors students during an examination. So you have those both options available to you. If I had to choose one or the other, I would strongly recommend going in person because online things can just go wrong and you don't want to have that problem. But it just depends on you, okay? And the last thing is, what does it take to pass the exam? So there are 3 components here. The first is to watch the video lectures and memorize key information. The second thing is to do hands-on labs and follow along with your own Azure account. We show you how to set up your own account in here, but when we get to those sections, definitely you should do it. Just don't watch it because that's going to make a huge difference to help you pass. And the last is to do paid online practice exams that simulate the real exam. You can pass the exam without using paid practice exams at the foundation level, which is this certification. It's much harder at the associate and expert level, so you're going to have to go get a paid solution. If you are going to go get paid practice exams, please do me the favor and use ours because it supports us able to produce this content. So don't go and use one of those other paid providers that do not provide free content, because for us, if we made enough money, we'd make everything free, and that's the whole point. So there you go. So now let's take a look at the exam guide and break down what it is that we're going to need to do to pass this exam and how we're going to have to study. So the first thing is the content outline. This is basically the general domains we're going to have to focus our time on. The first being cloud concepts. This is worth 15 to 25% of the exam. Then you have Azure core services. This is worth 30 to 35% of the exam. Then you have security, privacy, compliance, and trust. This is 25 to 30% of the exam. And then you have pricing and support, which is 20 to 25% of the exam. You'll notice that there are ranges here. So the thing is that it's not a guarantee that exactly 25% of the questions are going to be of that sort. So just be aware of that. Then on to grading. In order to pass this exam, you have to score a 700 out of 1,000. So generally, what you're trying to get is around 70% to pass. I say around because you could get exactly 700 and you could fail because Azure uses scaled scoring, meaning that the raw score that you get doesn't necessarily reflect the final score. So you're going to want to score a bit higher than 70%. So you want to aim for 75% or higher. The type of questions you'll see on the exam, we'll talk about here in a moment, but there are between 40 to 60 questions. So that means you have the chance of getting 12 to 18 questions wrong. I put an asterisk here because people who've actually taken the exam have reported only being presented with 30 questions. And I even reached out to Azure support to clarify that, to say, what is the real number? And their official answer was 40 to 60. But I know that when people are taking the exam, their experience is different. There's not much I can do about it. It's just that's what it is. It's going to be a bit fluid in terms of what your experience is going to be. But let's just go with this and say there's 40 to 60 questions. In terms of the format of the questions, you're going to see multiple choice. You're going to see multiple answer. You're going to see maybe drag and drop. And then you might see a hot area. Hot area usually just means like a couple drop downs where you have to answer 2 things at once. And the duration of the exam is 60 minutes. So that means you get 1 minute per question, roughly around that time. But the exam time is 60 minutes, but the seat time is 90 minutes. So seat time refers to the amount of time that you should allocate for the actual exam so that you have time that includes reviewing the instructions before you start your exam, re-accepting the NDA, completing the actual exam itself, which is the exam time, 60 minutes, and then provide feedback at the end of the exam, which is generally optional. And the last thing is, how long is this certification going to be valid for? And it's going to be valid for 24 months. So that means you're going to be able to hold on this for 2 years before you have to get recertified. So there you go. So now I just wanted to quickly show you the exam guide. They don't call their exam guide literally exam guide. It's the Microsoft Azure Fundamentals Skills Measured. And so this gives you pretty much the information for the breakdowns in terms of what stuff you might need to learn. But that doesn't mean necessarily everything that is listed in here is actually on the exam. But let's just quickly go through it so you have an idea. So the first is the cloud concepts domain. And in here, we need to know cloud terms such as availability, scalability, elasticity, fault tolerance, disaster recovery, agility. I've never seen that on the exam before, but they have it listed there. Then we have to describe the economics of scale, CAPEX versus OPEX, consumption-based models. Then you have to describe the different types of cloud models, such as infrastructure as a service, platform as a service, software as a service. Then we have to describe public, private, and hybrid cloud models. So there's that there. Then you have to know a bunch of different core services for Azure. So these ones, I would call them global infrastructure. They mostly have to do with networking. Then you have all your core services here. And then more core services or extended services, I suppose, then management tools. Then you have your security, privacy, compliance, and trust. So more networking components around security, but these don't really show up in the exam that much, but I've covered them anyway, just in case. Then Azure Identity, so that's creating accounts, giving access to people. The big one there is really Azure Active Directory. Then other security tools. So this is just knowing about things like the Security Center, which is a security tool, or just security services within Azure. Then we have governance. So this is going to be like policies, role-based access, just general access that has to do, but kind of with Azure identities up here. Then monitoring tools. Then we have compliance data protection standards. This is generally just pointing to websites. So the Trust Center is just a website that lists compliance information. Then we have describe pricing, SLAs, lifecycle. So understanding the subscriptions. So, free versus student versus enterprise. Then here, it's just a bunch of pricing. So like they have a pricing calculator and a TCO calculator and understanding the support plans. And then understanding the SLAs, and then there's lifecycle stuff like understanding general availability. So yeah, there you go. That's the exam guide outline. They have stuff down here below about changes. That doesn't really matter. But yeah, that is the exam guide outline. If you want more information about the actual exam policies, this page is really good for that. I got this from the Azure support team. So it says exam policies and FAQs. So this would be about like retiring certifications or like how to book your exam, or they would have information here about retake. So what would happen if you paid for it and like you missed it, or how many retakes would you get, or how long the exam hours are. So there's a lot of information here. So if you just want to go scroll through it, but yeah, here, like they don't say on the exam that it's 60 minutes. They just say, oh, for general fundamental exams, there's 60 minutes. So we just have to assume that's the time you get on the AZ900. But yeah, just check out that page and check this out if it interests you, but you don't really have to because we cover everything in the course that you need to know. But I just wanted those resources. I wanted to make you aware of those resources just in case. Hey, this is Andrew Brown from Exam Pro, and we're starting at the beginning of our journey asking the most fundamental question, which is, what is cloud computing? So looking into the dictionary, cloud computing is described as the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. So when we're talking about local, we describe this as being on-premise, so being your own office or your own data center. And so this is where you own the servers, you hire the IT people, you pay the rent or the real estate, you take all the risk. Whereas with a cloud provider, If you're utilizing them, it's someone else who owns the servers, someone else who hires the IT people, someone else who pays or rents the real estate, and you are only left with being responsible for configuring your cloud services and code, and someone else takes care of the rest. Sounds great, doesn't it? So now what I want to do is just give you a quick overview of how servers have evolved and what we describe as cloud computing from a technical perspective. And we'll probably dive deeper into this later in the course, but we're just going to get a good overview here to understand from a business perspective. So way back in the day, what we had was dedicated servers. If you wanted a server to run your web app or your technology, what you had to do is you had to go buy a single dedicated physical machine, and that was for one specific business. And dedicated servers are still used today, but there's some downsides with them. They're very expensive, they're high maintenance. However, you do get a great level of customization, and you potentially can have better security based on your use case. Then came along was virtual private servers. So we still had one physical machine, but and it was still dedicated to a single business, but we figured out how to take that physical machine and virtualize it into sub-machines. So now we could fully utilize or better utilize that physical server with running multiple apps. We didn't have to buy 4 different servers for 4 different apps. We could easily run 4 web apps into 4 virtual sub-machines. Then we had shared hosting. And so this made it a lot easier for anybody who's building websites or WordPresses. But the idea here is that you had one physical machine and it was shared by hundreds of businesses. So it wasn't a single business sharing the cost, it was multiple businesses. So this relies on most tenants underutilizing their resources though. So if you had 100 people on a server, and one person used more of the server than the others, then you could all potentially suffer from that case. But at the very least, you are getting very, very cheap servers, but there are definitely some limitations. So now coming down to cloud hosting gives us the best of both worlds. So we have multiple physical machines that act as one system, which it could be described as the cloud. And that system is abstracted away into multiple cloud services. So you get flexibility, scalability. It's very secure, it's very cost effective, and it's highly configurable. So that is where we're at. And so that is generally what cloud computing and cloud hosting is. Hey, this is Andrew Brown from Exam Pro, and we are looking at common cloud services. So a cloud provider can have hundreds of cloud services are grouped into various types of services. And the 4 most common types of cloud services for infrastructure as a service, and we'll talk about what that is later on, would be compute. So this is where you have a virtual computer that can run applications, programs, and code. Then you have storage. So this is where you would have virtual hard drives that you could store files. Then you'd have virtual networking because you have these computers and storage. So you need to put them in some kind of virtual network. And then you have databases. So just imagine a database that is running in the cloud, or if you're not familiar with databases, just imagine that it's Excel in the cloud, but it powers your web apps. And one thing I want you to know about the term cloud computing is that even though it says computing in the word, at this point, we just use it as a catch-all term. So it could refer to all of these categories. So when I say cloud computing, I could be referring to compute, network, storage, and databases. But you can also say cloud storage, cloud compute, cloud databases, cloud networking, and people will know what you mean. Hey, this is Andrew Brown from Exam Pro, and we are looking at what is Microsoft. So you've probably seen this logo before, and Microsoft is an American multinational computer technology corporation headquartered in Redmond, Washington. And Microsoft makes software, phones, tablets, game consoles, cloud services, which is what we care about here today. And they even have a search engine, and we're not just limited to that list, they have tons of stuff. But Microsoft is best known for their operating system called Windows, and they've been around since the 1970s. So they've been around for quite a while in the tech sphere. So now that leads us to the question is, what is Azure? So Azure is what Microsoft calls their cloud provider service. And so it's called Microsoft Azure, or we commonly refer to it as just Azure. And so here is the logo for it. And if you're wondering what is the name behind this service, it means bright blue color of the cloudless sky. So sure, that's great. And so you'll hear me say cloud service provider frequently throughout this course, and it is abbreviated to CSP, but that's what Azure is. It is a cloud service provider. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the benefits of cloud computing. So what are the benefits? Well, we have a big list here for you, starting with cost effectiveness. So you pay for what you consume. There is no upfront cost. You pay as you go, also abbreviated as PAYG, and you're sharing the cost with thousands of customers. So that's how you're getting that low cost. Another benefit is that you can go global. So launch workloads anywhere in the world, just choose your region. And you are now in the global market. Another benefit is the cloud is secure. So cloud providers take care of the physical security, and cloud services can be secure by default. Or you have the ability to configure access down to the granular level. So you have a lot of security controls that you would have that you would normally not have, or you'd have to build out on-prem. Now, the cloud is also known for being reliable, so you can have data backups, disaster recovery, and data replication and fault tolerance. The cloud is also scalable. You can increase or decrease your resources and services based on the demand. The cloud is also elastic, so you can automate scaling during spikes and drop the demand when there is no longer the demand for that stuff. And it's also current, so the underlying hardware and managed software is patched, upgraded, and replaced by the cloud provider without interruption to you. And I mean, that last one, there is cases of interruption, but generally fewer interruptions than you would have on-prem. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the different types of cloud computing, and we have this nice pyramid on the left-hand side to help us understand how each type builds off the other. Starting at the top of our pyramid, we have software as a service, also known as SaaS. And this is a product that is run and managed by the service provider. You don't worry about how the service is maintained, and it just works and remains available. So you might not be aware of this, but you probably already are using a SaaS product. So examples of that could be Salesforce or Gmail or Office 365. So those are things that would be considered SaaS, and these are really for customers. So it's just you wanting to use software, like general software on your computer, but in the cloud. The next category we have is platform as a service, abbreviated as PaaS. And so here we focus on development and management of your applications. And so you don't worry about provisioning, configuring, or understanding the hardware or OS. And this is really for people that are building apps, but they don't think about any of the infrastructure underneath. Services like this would be Elastic Beanstalk on AWS, Heroku, which is very popular amongst junior developers, which is a third-party service for launching web apps. And then you have the Google App Engine. So those are 3 examples there, and these are really for developers. So platform as a service makes it easy for developers to build apps on the cloud without worrying about all the stuff underneath. And at the bottom, we have infrastructure as a service, IaaS. And this is the basic building blocks of cloud IT. So provide access to networking features, computers, and data storage space. Don't worry about IT staff, data centers, and hardware. And this is the true focus of our course here, is focusing on this layer. But the thing is, again, on this pyramid is that the infrastructure service can have platform as a service and software as a service on top of it. And so examples of infrastructure service would be Microsoft Azure, AWS, or even Oracle Cloud. And so this is really intended for administrators. So that is the 3 types of cloud computing, and there you go. Hey, this is Andrew Brown from Exam Pro, and we were looking at the types of cloud computing responsibility. So we saw the 3 categories there. But we don't really understand what it is that we're responsible for and what is the cloud service provider responsible for. So let's lay out our categories, and we're going to include on-premise into this, because technically on-premise could be a private cloud and should be in the category here. So we have on-premise, infrastructure as a service, platform as a service, and software as a service. So when we're looking at applications, It's going to be the customer's responsibility for on-prem infrastructure PaaS. But when we have software as a service, the cloud service provider is responsible for that. When looking at the data level, it's going to be the same. For software as a service, the cloud service provider is going to be responsible, but for the rest, it's going to be the customer. And then on the next level, for the runtime, it's going to be responsible on the cloud service provider for the platform as a service and software as a service. For middleware, it's going to be the same. For the OS, like the operating system that is running on the service, it's going to be the same. Then when we get to virtualization, now it's the virtualization is responsible with the cloud service provider and above. And then for storage, servers, it's the same. For storage, it's the same. And for networking, it's the same. So you can see that on-premise, you're responsible for everything. And the farther we move up the types of cloud computing, the less responsibility you have. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure's deployment models. And the first model we're going to talk about is public cloud. And that's where everything is built on the cloud service provider. You're not using anything on-prem or in your own data centers. Everything is running within Azure. And generally, this is known as cloud native, but for some reason, Azure calls it public cloud. So that's what we're going to use in the terminology here. And so here I have an architectural diagram where we have a network on Azure, and within that network, we have a virtual machine running and a database running. So that would be an example of public cloud. Then we have private cloud. And so this is where everything is built on the company's data centers, also known as on-premise, because it's within the premises of the organization, like their physical location. And an organization could technically be operating their own cloud, but it would be private cloud, and they could be running some open source cloud software that mimics what Azure would do, such as OpenStack. So it looks very similar, but you just put an OpenStack in there, and it's running a virtual machine or a server, and it's also running a database. And the last on our list here is a hybrid. So with hybrid, you are using both on-premise and the cloud service provider, and they're connected together. And so there's a lot of different networking services that you can use that will facilitate the connection between the two. In this case, we're using ExpressRoute. ExpressRoute is a dedicated connection. It's like having a fiber optic line running from your on-premise data center to the Azure network. So it's just one of the ways you can connect. And if we wanted to understand like the pros and cons, I have this nice little table here, and we'll just quickly go through it. So if you're using public cloud, it's more cost effective. Security, its security controls are stronger by default, but some people might not find the cloud will meet all their security requirements because of government and regulatory reasons, not because the cloud is not secure, but it's just those policies. For level of configuration, it's going to be limited based on what the cloud service provider exposes to you. Still, there's a lot of configuration there. It's just that if you have your own servers, you obviously can do anything and everything with them. For technical knowledge, you don't need to have as much in-depth knowledge of the underlying infrastructure because you're not physically setting up servers or that networking and everything else. Now, coming down to private cloud is the most expensive option on our list. So you're going to be paying a lot of money there. For security, there is no guarantee that it is 100% secure because you just don't have the same kind of visibility that you would have with a cloud service provider with all those dashboards. It's just so hard to build out all that software, but you could meet your security compliance requirements depending on your situation. But this is becoming less and less as more governments and larger organizations move over to the cloud. You can configure infrastructure exactly how you like because you literally have bought the hardware and do anything you want with it. And the technical knowledge, you'll have to have a serious amount of technical knowledge. You might even have a really hard time finding the resources to maintain all that stuff. Then down below, we have the hybrid model. So this could be more cost effective based on what you offload to the cloud and also the cost of actually moving data back and forth. For security, you have more to secure. But technically, some things are easier to secure on the cloud than it is in private. So maybe you have a boost in security. You're going to get the best of both worlds in terms of configuration. And for technical knowledge, you're going to need to know both the cloud and like how to set things up on premise. So that's the most work there. And just one more deployment model here. I just want to talk about cross-cloud. This isn't something that is listed on the actual exam, but it's something that you should understand and know. And so cross-cloud is when you're using multiple cloud providers. Sometimes people refer to this as multi-cloud or hybrid cloud. And so I just have an example here. So there's a service called Azure Arc, and what Azure Arc does is it extends your control plane so you can run Kubernetes containers on different platforms. And so you could have AWS on the left-hand side with EKS and GCP Kubernetes engine. And so you could be running virtual machines and they're all treated like they're on the same network. So cross-cloud is becoming very popular with extremely large organizations where they have very unique requirements. But I definitely wanted you to know what that is because it just gets left out. And it's definitely something that is part of the industry. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of total cost of ownership, TCO. So what is the difference between on-premise, so having your own data centers, and then using Azure? And you'll notice above it, it says CAPEX and OPEX. We're going to talk about that in the next slide. But for the time being, we're going to focus on the total cost of ownership. So to really make sense of this, I always use this graphic here. And if you're wondering what that is, those are icebergs. People sometimes think they look like teeth. And so just to make this drawing a little bit more clear, I've added some penguins and a whale, so there's no mistaking it. And the reason we're using this as a representation is because we have the top of the iceberg, which are the costs that we're generally concerned about, but then we have those hidden costs, those costs that we're not really thinking about that is underneath the water. And if you know icebergs, they can be really big underneath. You don't know. So on the left-hand side, the cost that we generally think of is the software license fees. And then for the cloud service provider, we look at the subscription fees. And so when you're comparing these two, sometimes the subscription fees can cost more than the software license fees. So you'd think, well, we should really just use on-prem because it's more cost effective. But when we take in the total cost of ownership, all the costs involved, we're going to see a very different picture. So on the left-hand side, if you are on-premise, you have to deal with the implementation, the configuration, and the training, but you also have to deal with the physical security of your building. You have to pay for the hardware. You have to pay for the IT personnel. You have to deal with maintenance. Now, on the right-hand side on the cloud, you still have to do implementation and configuration and training, but that's about it. So there's a big difference in terms of what you have to do. And you might ask, okay, well, what is the amount of savings? Well, generally people find that when they move from on-prem to the cloud, they save 75%. That's a lot of money, okay? 75% of what you generally would spend. And so now all this stuff on the left-hand side is now Azure's responsibility. You don't take care of those anymore. Azure's going to take care of it for you. So that's total cost of ownership. Hey, this is Andrew Brown from Exam Pro, and we're looking at capital versus operational expenditure. So on the left-hand side, we have CAPEX, so capital expenditures. On the right-hand side, we have operational expenditures, OPEX. And so looking on the left-hand side, capital expenditure is spending money up front on physical infrastructure. So deducting the expenses from your tax bill over time. A lot of companies, larger companies, are used to dealing with capital expenses and they know how to work their tax bill. And so that's why a lot of people are afraid to move over to the cloud because they're used to this way of operating. But let's talk about some of the things that would be considered a capital expense. So again, it's anything that's physical and then you're buying it with money up front. So computers, so that would be your server costs. If you were to buy hard drives, that'd be your storage costs. If you bought routers, cables, and switches for your network. If you were purchasing things for backup and archive costs. If you had disaster recovery, so like an uninterruptible power supply would be an example of that. You have your data center costs, so that's your rent, cooling, physical security. Your technical personnel, so you're hiring people to do things for you. And so with capital expenses, you have to guess upfront what you plan to spend. Now let's look at operational expenditure. So operational expenditure is the cost associated when an on-premise data center has shifted that cost to the service provider. So here, in this case, it's the cloud service provider. And the customer only has to be concerned with non-physical costs. So what's examples of OPEX costs? Well, leasing software and customizing features, training employees in cloud services, paying for cloud support, billing based on the cloud metrics, so compute usage and storage usage. And the advantage here is that with operational expenses, you can try a product or service without investing in equipment. So We have flexibility of investment, and we also, from the previous slide, we saw that we have a huge reduction in cost. So there's two reasons, really good reasons to use the cloud. Hey, this is Andrew Brown from Exam Pro, and we are looking at cloud architecture terminologies, and these are very important to help you conceptualize the advantages of the cloud. And so we're going to go through these terms, and then we're going to go through them again in more detail in further slides. So at the top of our list, we have availability, and this is your ability to ensure a service remains available. And this is generally known as being highly available or high availability, abbreviated to HA. That's a term you should know. Then we have scalability, so your ability to grow rapidly or unimpeded. Then you have elasticity, so this is your ability to shrink and grow to meet the demand. You have fault tolerance, this is your ability to prevent a failure. Then you have disaster recovery, this is your ability to recover from a failure. And this is known generally as being highly durable or high durability, DR. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of high availability. So this is your ability for your service to remain available by ensuring there is no single point of failure or ensure a certain level of performance. So here I have a technical architectural diagram that is describing high availability. So the idea behind this is that if you have a server which runs your web application, if you were to run redundant versions of your server, if anything happened to a single server, traffic could always be routed to those other servers, and that way your service would remain available. Now, having multiple servers is great, but even what's better is having multiple servers in multiple data centers, because something could happen to a data center. It could become unavailable because of a networking issue. So by being able to route traffic, or that way, you're going to remain highly available. And running a workload across multiple availability zones, and availability zones is what Azure calls their data centers, ensures that if one or two data center becomes unavailable, your service will remain available. Very, very common to run at least 3 servers across 3 data centers. Now, how would you distribute the traffic or manage the traffic to all 3? And that's where an Azure load balancer comes into play. That green triangle with the arrows, that is the representation of a load balancer. So a load balancer allows you to evenly distribute traffic to multiple servers in one or more data center. And if a data center or server becomes unavailable, so unhealthy, the load balancer will route the traffic to only available data centers with servers. So there you go. That is high availability. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of high scalability. And this is your ability to increase your capacity based on the increasing demand of traffic, memory, and computing power. If you are a growing company, you're going to have to scale up. You're going to have to get bigger and better servers. But there are different types of scaling, and the first type is vertical scaling. This is the most obvious one people are going to think of, and it's called scaling up. And what we do is we just upgrade to bigger servers. We need bigger hard drives, faster computers. That's vertical scaling. But there's another kind of scaling called horizontal scaling. And horizontal scaling is described as scaling out. And what you're doing is you're just adding additional servers, because we saw with the high availability, we have a load balancer. We can distribute traffic to multiple servers, and 3 servers can equal the same thing as one big server. So horizontal scaling is when we add more servers of the same size. Hey, this is Andrew Brown from Exam Pro, and we're looking at the concept of high elasticity. And this is your ability to automatically increase or decrease your capacity based on the current demand of traffic, memory, and computing power. So this sounds a lot like high scalability, but the key difference is that it's automatic and you can decrease the demand, not just increase it. And so the way we would do that is that we would have a virtual machine or server, and if we needed more servers, we would add more servers, and if we needed less servers, we would remove less servers. And so this is going to be accomplished using horizontal scaling. So when we say we're scaling out, this means we're adding more servers of the same size. When we're scaling in, this means we're removing more servers of the same size. And generally, you're not going to use vertical scaling for high elasticity. It's just extremely difficult to vertically scale, because if you have to increase, let's say, your storage drive, and then you decrease it, you could lose data. So it's not a good idea or even feasible to do vertical scaling with high elasticity. Now, how would you accomplish being elastic on Azure? Well, you'd use Azure's VM scale set. So scale sets automatically increase or decrease in the response to demand or based on a defined schedule. And we'll talk about those in greater detail later in this course. And then we have SQL Server or Server Stretch Database. These dynamically stretch warm and cold transactional data from Microsoft SQL Server 2016 to Microsoft Azure. Not something we're going to cover, but it's generally the same concept that scale sets do. So there you go. That's high elasticity. Hey, this is Andrew Brown from Exam Pro, and we're looking at the concept of high durability. So this is your ability to recover from a disaster and to prevent the loss of data. So this could be solutions that recover from a disaster is known as disaster recovery, DR. And so I'm just going to ask you a bunch of questions to help you think about how to be highly durable. So one question would be like, do you have a backup? So do you have a backup in place? How fast can you restore your backup? Does your backup still work? How do you ensure current live data is not corrupt? So that is the concept of high durability. There's a variety of services to implement it. So it's not just a single service. But there you go. That is the full list of cloud architecture terminologies. Hey, this is Andrew Brown from Exam Pro, and we are looking at the evolution of computing. And this is going to really help you to understand the different layers of compute. And so we're going to start from on the left-hand side to dedicated and work our way all the way to functions. So what I want you to know is that when we're talking about dedicated, this is a physical server wholly utilized by a single customer. And so the idea is that this customer has purchased this dedicated piece of hardware. But the thing with this is that you have to guess your capacity. So when you buy it, it's like a capital cost, or you're purchasing for like the whole, like you have to plan how you're going to fully utilize it. So you're going to overpay and you're going to have underutilized servers. And the reason why is that when you first launch your app, it might be small and then you're expected to grow into that space, but you're just not using that space until you grow into it. So it's considered wasted. If you want to upgrade beyond your capacity, this is going to be slow and expensive. You literally would have to buy a new server that's larger and then move everything over. You're going to be limited by your operating system. So whatever operating system is installed, that's what you're going to have. You're going to have multiple apps. If you do install multiple apps onto a dedicated server, you might have conflicts in resource sharing, but generally it's recommended to only have a single primary application on a dedicated server. You are going to have a guarantee of security, privacy, and full utility of the underlying resources, because that's the whole purpose of having a dedicated server is. Sometimes dedicated servers where you have full control of everything is called bare metal. And that's basically mimics what it was like to have a server on premise or back in the day. And they still exist. So that is dedicated. And we'll move on to VMs. So now we're moving on to virtual machines, also known as VMs. And so the idea here is that if you had a physical server and you had the capability of running virtual machines, that's like running a machine within a machine. And so now you're able to run multiple applications on a single machine. The technology that's used to actually run VMs is known as hypervisor. There are some other kinds, but the ones we need to know is hypervisor. So just know that that's the software that makes virtual machines work. You are now sharing the physical server with multiple customers. That is generally a good thing because you are paying a fraction of the server cost. You don't have to buy that server outright. You are still going to be overpaying for the underutilization of a virtual machine, because it still has that issue of wasted space, because you have to choose a particular size of virtual machine. It's not going to be perfectly fit for your application. You are going to be limited by your guest operating system. So whatever OS that you've chosen, that's what you get. So that's what you have there. If you want to run multiple apps on a single virtual machine, they can still result in conflict resource sharing. But now customers that are isolated from you aren't going to conflict with you. So you could run if you had 3 apps, you could run them as 3 virtual machines. So you're not gonna have that issue. But if they're on the same VM, you still have that issue. So there you go. That is virtual machines, and we'll move on to containers. Hey, this is Andrew Brown from Exam Pro, and we are looking at the concept of containers. And so this takes it a step further, where we have virtual machines and we're running multiple containers. So we're further subdividing the way that we run our applications. And the technology that is used to run containers within a VM or on a physical server is called Docker Daemon. If you're using Docker for containerization, that's the most common one. But that's going to let you run multiple containers, and you can maximize the utility of the available capacity. So this is extremely more cost effective, right? So that available space is always there for you to launch more servers within, or you can expand the usage for your app to take up that available space. Your containers share the same underlying OS, so the containers are more efficient than multiple VMs. But the great thing is that you can have different OSs. So the idea is that each container can technically be running a different OS. And so now you have a lot more flexibility. It doesn't seem like you could improve upon this further, but we will when we move over to functions. So now we're going to take a look at the evolution of computing for functions. And I bet you didn't believe it, but we subdivided it even further. And so we've taken our applications that were running containers and we broke up the apps into little pieces of code called functions. And now we even have more or better utility of our compute. So we have a managed VM running managed containers. So we don't have to worry about the containers or configure them ourselves. Functions are usually taken care of. This is known as serverless compute because you don't set up anything. You just put your code online and it just works. You might choose the memory and the duration that you need to utilize, and that's all you pay for. You're only responsible for your code and data and nothing else. And it's extremely, extremely cost effective, right? Because you are just paying for that individual function to run, and all that underutilized space is the problem of the cloud service provider. It's not your issue. The only downside is that there is a concept called cold starts, meaning that when you launch a function or serverless code, it generally has to provision a server because the cloud service provider doesn't want to be running servers when they aren't being utilized. So you might experience a cold start where you're waiting for a server to start before your code will execute. But there's definitely ways around that. So there you go. That is the evolution of compute. Hey, this is Andrew Brown from Exam Pro, and we are looking at regions and geographies for Azure. So a region is a grouping of multiple data centers, and for Azure, they call their data centers availability zones. Azure has 58 regions available across 140 countries. One thing Azure likes to promote is that they have the most regions out of all cloud service providers. Then we have something what we call a geography. So a geography is a discrete market of 2 or more regions that preserve data residency and compliance boundaries. And the geographies that are available for Azure, we have the United States. Then there's Azure Government US. This is a geography that's only for the US government. So regular citizens cannot use it. Then you have Canada, that's where I'm from, Brazil, and Mexico. And I just want to emphasize that data residency and compliance boundaries for geography. And I just want to give you an example. So imagine you live in Canada and you work for a Canadian company. You want to guarantee that the data will remain within Canada for whatever government regulatory reasons. So then you'd want to use the Canada Azure geography because that data would never leave Canadian soil. So that's the case there. And I just want to give you kind of a visual example. So on the left-hand side, we have 2 regions. We have US East 1, and we have the Europe Norway East region. And in those regions, I'm not showing it here because I don't want to make it too complicated, but there would be availability zones, and we could launch resources. So we have some servers, virtual machines. Those are the images you see within the regions. And generally the way regions work in Azure is that when you go to launch a resource, you choose the region at that time of creation. So if you're launching a virtual machine, it's going to give you an option to choose a region, and you just choose from that list. So yeah, there you go. So I just made my way over to Azure. So I just typed in Azure Global Infrastructure because I just wanted to show you the big map of all the regions and where Azure is available all throughout the world. Because sometimes it's nice to look here. So we can see we have stuff down in Australia. We have regions in Africa. We have a region in South America. We have a lot in North America. We have a lot in Western Europe. And then we have some in Asia here. So we have Japan, China, all over the place. So, if you want to look a little bit more into that, there's a lot of good information here on the global infrastructure pages. But that's about it. I just wanted to show you that world map. So now we're looking at paired regions. So each region is paired with another region 300 miles away. And the reason why Azure does this is so that if one region is being updated, then the other one is still available, meaning that if you're planning to make sure that you never have downtime, you can put your resources in that paired region, and then you're going to have higher availability. So some Azure services rely on paired regions for disaster recovery. So when you turn those services on, they're automatically going to launch in that paired region. One service which would help you leverage your paired region would be a service called Azure. It's a feature of storage, but it's called Azure Geo-Redundant Storage. So it replicates your data to secondary region automatically, ensuring that the data is durable even in the event that the primary region isn't recoverable. And just to give you an example of a paired region, so let's say we're talking about Canada. So with Canada, you'd have Canada Central, and then its paired region is Canada East. For North America, and when we say North America, we're really talking about the United States. It's East US region paired with the West US region. And then for Germany, you have Germany Central and Germany Northeast. So it gives you an idea how far away they are, 300 miles. That's quite a distance. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at region types and service availability for Azure. And what I want you to know about service availability regarding regions is that not all cloud services are available in every single region. And there's infrastructure reasons as to why, and there's compliance reasons as to why. So Azure has two types of regions. They have recommended regions. These are regions that provide the broadest range of service capabilities. What that means is that the majority of services are going to be available in this region. And this recommended region is designed to support availability zones. Then you have alternate regions. And these are regions that extends Azure's footprint within a data residency boundary where a recommended region also exists, but they're not designed to support availability zones. That doesn't mean you can't launch resources within them. It just means that when you go to launch a resource, you're not going to choose an availability zone. And these regions are labeled as other when you're in the Azure portal. Now let's talk about general availability. So general availability, abbreviated to GA, is when a service is considered ready to be used publicly by everyone. So if you have a service or product and it was in beta and now you're ready to sell it to people, that means that it's GA. But just because it's ready to sell, there's also the conversation around whether it's actually available to use. And that's going to be determined based on the category that the Azure Cloud Service is in. And so Azure categorizes three different types of availability for services. And the first one is foundational. So a cloud service that is foundational is going to be available immediately in a recommended and alternate regions when it goes GA, or at least in 12 months of the time that it was announced. Then you have mainstream. So these are cloud services that will become immediately available in a recommended region or in 12 months when it goes GA. But for the alternate region, it may become available based on the customer demand. And then the last one is specialized. So cloud services that are in this category will become available in recommended or alternate regions based on customer demand. So hopefully that clears up service availability and region types. Hey, this is Andrew Brown from Exam Pro, and we are looking at special regions for Azure. So Azure has specialized regions to meet compliance or legal reasons because they might want to work with specific governments and to meet those requirements, they basically give them their own region. And so the first on our list is the U.S., and we have three regions that we know about. So we have the U.S. Department of Defense Central, the U.S. Government Virginia region, the U.S. Government of Iowa region, and then we have an additional three that we just don't know about it because they're in secret locations. So maybe they're for Area 51. We don't know. And so the reason why they have these special regions is that if you just want to do business with the government, they need these kind of regulations. Then on the other side, we have China. And so they have a region in China East and China North. And these regions are available through a unique partnership between Microsoft and 21 Vianet. And so Microsoft does not directly maintain these data centers, but they work with 21 Vianet to give you accessibility to these regions. And probably to operate these regions, you'd probably be a citizen of these countries, and you'd also be an employee of the government. So it's not going to be for us citizens to use. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at availability zones for Azure. And so availability zones abbreviated to short for AZ, and you'll hear me using that abbreviation a lot in this course, and you should learn to remember that as well. It's a physical location made up of one or more data center. And so a data center is a secured building that contains hundreds of thousands of computers. And if you want a little visual, here is the inside of a data center. And there's a technician working on a rack of servers, and there's a dog in the data center. You should definitely never have a dog in your data center. You'll probably hear me refer to availability zones as a data center because it's the easiest way to think of it, but it actually can be more than one data center. Now, a region will generally contain 3 availability zones. I say generally here because there are cases where there are less than 3, but there's actually very specific reasons as to having exactly 3 availability zones. Data centers within a region will be isolate from each other, so they'll be in different buildings, but they will be close enough to provide low latency. And that low latency would probably be in the sub-milliseconds. I don't know what it is for Azure, but that's generally how it would be designed because you want it to feel like it's on the same network. It's common practice to run workloads in at least 3 AZs, and that's why I was saying that earlier. That's important to ensure services remain available in the case 1 or 2 data centers fail, and this is called high availability, and we'll definitely cover this concept again in this course. Just to give you a bit of a visual, on the left-hand side, what we have is a region called US East 1, and we have multiple availability zones. Azure just labels them 1, 2, and 3. And so when you go to launch a resource, if you look on the right-hand side, you choose your region. So we are choosing US East US. Then we are saying we're going to use availability zone, and then we choose which one we want to launch it into. So if we choose 2, it's going to go into availability zone 2. That doesn't mean we're going to launch 2 instances. It just means availability zone 2. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at AZ supported regions for Azure. And so not every region has support for availability zones. And we touched on this in the region section, but we'll touch on it here again. So we know that there are regions called alternate or others, and these do not have availability zones whatsoever. Then you have recommended regions, and these are supposed to have 3 AZs. The reason why they might not have them is because it's a newer region, and Azure is promising to add more regions within 12 months or whatever time period that they say. But generally what you want to do is when you have cloud resources, you want to launch them where they have at least 3 AZs. So which regions actually have 3 AZs? And that is Central US, East US 2, West US 2, West Europe, France Central, Northern Europe, Southeast Asia. So that is where you generally want to run your workloads. Now, what does it look like when you try to go launch a resource and you choose a region that doesn't have an availability zone? What's that going to look like? Well, it's going to look like this. So you're going to availability zone is going to be blanked out, and you'll have to choose no infrastructure redundancy required. And so that would be the example for Brazil South, where it's just there is a single AZ, but it's described as not having an AZ, so you just don't choose it in the interface. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at fault and update domains. So an availability zone in an Azure region is a combination of a fault domain and an update domain. So a fault domain is a logical grouping of hardware to avoid a single point of failure within an AZ. And so basically it's a group of virtual machines that share a common power source and network switch. The reason why Azure does this is that so if part of the data center fails, then other servers won't be taken down with it. So let's say there's a fire within the data center in one particular region, it won't affect other hardware that is running. Then you have update domains. And so update domains is when Azure needs to apply updates to the underlying hardware and software. But the thing is that because Azure is updating them, it takes these machines offline. So the idea is that if you run your workloads in another domain, in the update domain, neither domain will be updated at the exact same time. And that way you won't have downtime because of updates. And so the way fault domains and update domains work is that you use availability sets. So availability sets is a logical grouping that you can use in Azure to ensure that your VMs you place in the availability set are in different fault update domains to avoid downtime. And just to really help with that visual here, what I'm going to do is just show you this here. So each virtual machine and availability set is assigned a fault domain and an update domain. And so what you're looking at here is, you see those gray boxes? Those are racks in your data center. A rack is just like, it's like a closet for servers, and all those servers sit on top of each other. And so each of those servers in that is where your virtual machine might be deployed. So if you have a server and it's deployed in fault domain 0 and fault domain 1, it could be in any of the servers on that rack. But then update domains, you just might have very particular servers in that rack that are those update domains. So hopefully that makes that a bit clear. I know it's a little bit confusing, but just remember the concept behind fault domains and update domains. And just to give you a visual of what it would look like in the Azure portal, if you go ahead and create availability set, you would name it. So here I call it production, and you would choose the fault domains and you would choose the update domains. And so I believe that what you're doing there is that you're choosing the amount of domains that you want your virtual machines to be distributed across. And I keep on saying virtual machine, that's your server, okay? So if you say 2 fault domains, that means that when you launch 2 servers and you put them into that availability set, they're going to be across 2 different fault domains. And if you launch 5 servers and your update domains is at 5, that means it's going to be across 5 different servers that are isolated from each other. So hopefully that makes sense, but that's fault and update domains. So I quickly just wanted to show you the fault and update domains that are in Azure here. So the idea is if you're launching a virtual machine and you want to control the availability set, what you can do is you can go down to here where we have availability options. We're going to drop it down and choose availability set. And then we don't have an availability set, so I'm going to go ahead and create one. If I just click there. And so when we create a set, we can say, production set. And so we have these two dialogues here. And so what it is when you say there's 3 fault domains, that means that if you were to launch 3 VMs and you put them all into this availability set, it'll be spread across 3 different racks so that if a rack goes out, 2 other racks are operational, and so your service will remain available. And then down below, it's the same thing. On a rack, there might be multiple machines, and certain machines will be scheduled for updates, but they won't all be updated at the same time. So if you're saying this, you'll say spread it across 5 machines, and that's all there really is to it. So I just wanted to show you where that was when you actually launch it for a virtual machine. Hey, this is Andrew Brown from Exam Pro, and we are looking at creating ourselves our own Azure account so that we can get some hands-on experience with Azure. So what I've done here is I've gone to azure.microsoft.com, and that's what I want you to do as well. And then when you're here, just look for free account. They have it everywhere, so they have it here, and they have it here, and I bet you could even get it through sign-in. But what I'm going to do is just click free account here in the top right corner. And then when I'm here, we're going to have another start free button, so we'll go ahead and click that. And so now we have to log in with our Microsoft account, or if you don't have one, we'll create one. I'm going to create a new one. And I created an email just for this tutorial here. It's called azure@exampro.co. And I'm going to need to set a password. So I'm just going to go off screen and generate myself a password. Great, so I just generated myself out a very strong password, and I'm just going to paste that in there, and I'm going to proceed forward. And so the next thing it's going to ask is it's going to send me an email to my email there, and I'm going to have to enter a verification code. So I'll be back here in a moment to show you that code. Okay, so I went ahead and checked my email, and immediately I received a verification code. So mine is 6599. Yours is going to be different. So I'm just going to go ahead and enter mine in here. So it was 6599. And I'm good. I don't need any tips or offers. And then we'll proceed to next. And so now, before we proceed, we have to complete this challenge here. So let's give it a go. So we have X and 5, W, 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 Q. All right, and so after waiting a little bit for this page to load, we have some information. So we have to fill in our about you, so our country, our first name, last name, email, phone number, identity verification by phone, identity verification by card. Oh, wow, they have a lot of steps here. And so we will make our way through here. So now I'm just going to go ahead and fill in this information, and I'll see you here in a moment. So I just filled in the About You section here. And so what I'm going to do is I'm going to just proceed to Next. And so now it's going to ask me to verify my identity by phone. So I want a text message, so I'm going to click the Text Me button. And so I'm just going to check my phone for that verification code. And so I've received the text message for the verification code. I'm just going to go ahead and enter that in. So mine happens to be 351033. Your code's going to be different from my code. I'm going to go ahead and verify that code. All right, and so it looks like it's going to ask us to identify our verification by card. So we're just waiting for something to load here. And so what we're going to have to do is we're going to have to enter in credit card information. So we'll just go ahead here and fill that in. So I have gone ahead and filled in my credit card information. I'm just going to proceed to Next. Great, and so now that it's been verified, I can go ahead and just go ahead and click on the agreement. So I'm going to say I agree to the subscription. And the second one, I do not have to check box. That's if I want to get tips and offers. But the first one, I'll definitely check box because we have to, and we'll go ahead and sign up. Great, and so now we are here, and it looks like we are ready. I guess you could schedule a live demo, which seems very generous of Azure, but I'm just going to go ahead and proceed to the portal. And so here we are, we made it into Microsoft Azure, and what you're looking at right now is the portal. It's telling me I have $260 worth of credits. If you're wondering why it's higher than yours or lower than yours, notice that it's in Canadian dollars. So I believe that it's 200 USD. When that's converted in my currency, it's a bit higher. And so it might be different for you. But there you go. That's all we had to do to create the account. And now we can actually start learning other things in Azure. Hey, this is Andrew Brown from Exam Pro, and I just wanted to quickly show you that you can change the experience of your Azure portal. If you just go all the way up here and click the cog, you can switch the default view from home or dashboard. You can change the flyout here so it's docked, which is a lot easier when you're navigating stuff all the time. And if you want to change your theme, you could go to a dark mode here, or even you can do a high contrast. So very old school, but very easy on the eye. So just wanted to make that aware to you because you may feel that you want to change your experience right off the bat. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Computing Services, starting with Azure Virtual Machines. So virtual machine is going to be the most common type of compute. Whenever you're launching a server, I would just think of a virtual machine. And your virtual machines can either be running Windows or the Linux operating system. Now, the great thing with virtual machines is you get a lot of configuration, so you can choose your OS, the amount of memory, the amount of CPU, you can attach storage to it. The thing here is that because it's a virtual machine, the hardware is shared with other customers. You can get dedicated, but generally it's shared. And then you get a virtual computer, so it seems like you have like 100% of the resource, okay? Then we have Azure Container Instances. So this I would describe as Docker as a service. You can run containerized apps. Probably runs Docker in both Windows containers, because I believe Windows has containers as well. But runs containerized apps on Azure without provisioning servers or VMs. So it makes that a lot easier for you. The next sounds very similar, which is called Azure Kubernetes Service. So it's Kubernetes as a service, easy to deploy, manage, and scale containerized applications. So the idea here is that Kubernetes is just another way of working with containers. but it's using an open source library. Kubernetes has basically become the de facto for containers. And so we've seen all the cloud providers try to make their own service or orchestration service, but Kubernetes kind of won out. So you'll see it on all platforms. The next one is Azure Service Fabric. This one can be a bit confusing because it's described as many things, but I'm going to describe it here as a tier 1 enterprise container as a service application or a cloud service. So it's for distributed system platforms. It runs on the Azure cloud or on premise. And the way they described it is easy to package, deploy, and manage scalable and reliable microservices. And anytime you hear the word microservices, think of also containers. So with Azure Container Instances and Azure Kubernetes Services, that's where you'd also run microservices. Then we have Azure Functions. So this would be event-driven, serverless compute. Anytime we're talking about serverless compute, we're usually talking about serverless functions, which are little bytes of code that you can just upload, and it just works. You don't have to think about the servers or provision anything, and you only pay for the time that code runs. So serverless functions generally run for a very short duration, and as soon as they're done, those underlying servers are shutting off. And the last on our list here is Azure Batch. So you can plan, schedule, and execute your batch compute workloads across 100 plus jobs in parallel. When I say jobs here, it's just the code that you want to run. You can use spot VMs. Spot VMs might not be out at the time of this, but it will be in the future. But generally it's known as low priority VMs. But the idea here is that there are virtual machines that are being underutilized. And so Azure is allowing you to rent them at a more cost-effective cost. And so if you're doing a lot of scientific compute or other things, and it doesn't matter if these services get interrupted and you want to use those low priority VMs, that is a great way to save, and that is the computing services. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Storage Services, starting with Azure Blob Storage. So I would describe this as object serverless storage. So if you ever heard of object storage or serverless storage, this is going to make sense to you. So you're able to store very large files and large amounts of unstructured files. And the idea here is that you pay for only what you store. It's basically unlimited storage. You don't have to resize the volumes. You don't have to worry about file system protocols. You just upload files. And that's why it's considered serverless storage. Then we're going to move on to Azure Disk Storage. This is the most common type of storage you'll encounter. We can describe it as a virtual volume. So you're just choosing either an SSD or an HDD. So it's basically a hard drive in the cloud. It has encryption by default, and it's attached to virtual machines. So anytime you're spinning up a virtual machine, it's probably spinning up also Azure Disk Storage attached to it. Then you have Azure File Storage. So this is a shared volume that you can access and manage like a file server. So it's going to use protocols such as SMB. The reason you'd want this is that, let's say you had multiple virtual machines, multiple servers, and you wanted them to all share the same hard drive. That's what you'd use it for. Or if you need to have users access it using those protocols, that's another way of doing that. Then you have Azure Queue Storage. Now I put an asterisk in front of it because this is just a weirdly named service because this is really for a messaging queue. This is actually for application integration, but I list it here because they put the word storage on it. So I just think it's poorly named. And even the way they describe it is just makes you think it's storage, but it's a data store for queuing and reliably delivering messages between applications. So it's just integrating two applications together, passing messages along. Another one that's confusing is Azure Table Storage. I would put this in the database categories, and it's a NoSQL database, and specifically it's a wide column NoSQL database. And as they describe, it's a NoSQL store that hosts unstructured data independent from any schema. So just be aware of those two. They're just very poorly worded. Then you have Azure Data Box, and also its upgraded version, the Azure Data Box Heavy. This is a rugged briefcase computer and storage designed to move terabytes or petabytes of data. So imagine somebody shows up at your door with this tower that's a computer, and you plug in your USB or whatever you want, and you transfer all your files locally on your on-premise data center, and then they ship it because it's faster to ship the data on a physical piece of device than it is to send it over the internet. That's what Azure Data Box is. And then we have Azure Archive Storage. So this is long-term cold storage for when you need to hold onto files for years, but you want the cheapest storage options. If you have lots of data and it's not doing anything, you definitely want to be putting it on the cheapest possible storage devices. Cheap meaning doesn't mean that they're not reliable. It just means that they're not active. The disks are not actively spinning. Nobody's accessing the data on those hard drives. The last one is Azure Data Lake Storage. And so this is a centralized repository that allows you to store all structured and unstructured data at any scale. When you're working with big data from multiple different sources and you need it to be in one place, that is the service for you. And so that is the Azure Storage Services. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Database Services. Starting at the top of our list is Azure Cosmos DB. This is a fully managed NoSQL database. It's designed for scale with guarantee of 99.999% availability. Azure loves talking about this database. It's their flagship database because it works at incredible scale and an incredible performance. So whenever you're thinking about like super large databases, think of Azure Cosmos DB. Next on our list is Azure SQL Database, and even though it doesn't have it in its name, this is for the MS SQL engine. So if you're running Microsoft SQL, you're going to want to use this. It's fully managed with autoscale, integral intelligence, robust security. So there's a lot of great features built around this for MS SQL databases. Now, if you're not using MS SQL and you're using something like MySQL, Postgres, or MariaDB, they have Azure Database. So it's fully managed and scalable with high availability and security. Then you have SQL Server on VMs. Again, it doesn't have it in its name, but it's Microsoft SQL Engine. Okay, anytime it says SQL Servers, just assume that it's the Microsoft flavor of SQL. And the idea for this one is that if you already have SQL servers running on premise within your data center and you want to move them onto Azure, this is where you'd use a lift and shift. So it takes those virtual machines and directly moves them onto the cloud. You don't get all the functionality that you would with Azure SQL database, but it's the easiest way to get onto the cloud. Then you have Azure Synapse Analytics, previously known as Azure SQL Data Warehouse. It's because they added an analytics component to it, but it's a fully managed data warehouse with integral security at every level of scale at no extra cost. Then you have Azure Database Migration Service, so migrate your databases to the cloud with no application code changes. So there's that service. Then you have Azure Cache for Redis. So if you need an in-memory cache that is using the open source Redis, you can use that. And last on our list is Azure Table Storage. We mentioned this in the storage services, but to me, this is a database. It's not a storage service, even though it's named as such. So wide column NoSQL database, a NoSQL store that hosts unstructured data independent of any schema. So there you go. That's the Azure Database Services. Hey, this is Andrew Brown from Exam Pro, and we are looking at application integration services on Azure. Now, I didn't have room on the slide for this, but just to tell you what application integration is, these are services that are designed to help apps or services talk to each other. So it's basically the glue of services. The first on our list here is Azure Notifications Hub. This is using publisher subscription technology underneath, and this is for sending push notifications to any platform from any back end. Next, we have Azure API Apps. So this is essentially an API gateway, so you can quickly build and consume APIs in the cloud, and then those APIs will have API endpoints, and you can route them to Azure services or maybe functions or containers, but it's a way of building an API in the cloud. Then you have Azure Service Bus, and as the name implies, it is a service bus. So reliable cloud messaging as a service, MaaS, and simple hybrid integration. I know that's not very clear. That is the language that Microsoft uses to describe it, but just what you need to know is that it is a service bus. Then you have Azure Stream Analytics. So this is serverless real-time analytics. Remember that word real-time and think of this service from the cloud to the edge. Then you have Azure Logic Apps. So you can schedule, automate, orchestrate tasks, business processes, and workflows, and it integrates with enterprise SaaS and enterprise applications. Then you have Azure API Management. This can be confusing because we have another service called Azure API Apps. I don't know what we would generally call this service. They say it's a hybrid multi-cloud management platform for APIs across all environments, whatever that means. But when I looked at it, what it does is you can put this in front of an existing API to add additional functionality. So if you have an API, you put it in front of it, and it's basically a proxy to your API, and then you get all this additional stuff. Then last on our list is Azure Queue Storage. We saw this in our storage service sections, and I had said that I don't really consider this a storage service. I consider it an application integration service. And this is a messaging queue. So it's a data store for queuing and reliably delivering messages between applications. So there you go. That is the application integration services on Azure. Hey, this is Andrew Brown from Exam Pro, and we are looking at developer and mobile tools that are commonly used with Azure. So the first on the list is Azure Signal R service, and this is a real-time messaging service, not to be confused with Azure's notification service. This is for easily adding real-time web functionality to applications. So if you ever heard of Pusher, it's just like Pusher. So that is the equivalent there. The next we have is Azure App Service. So easy to use service for deploying and scaling web applications with .NET, Node.js, Java, Python, and PHP. I'm a bit sad I don't see Ruby in there, but what are you going to do? So it's for developers who want to focus on building their web apps and not worry about the underlying infrastructure. So if you've ever used Heroku, think of it like that, but for Azure. Next, you have Visual Studio, and Visual Studio is a code editor. It's basically an IDE, an integrated development environment designed for creating powerful, scalable applications for Azure. You might have heard of Visual Studio Code, which is similar but different. But I just wanted to make mention of Visual Studio here. Then you have Xamarin, I think I'm pronouncing it right, and it's a mobile app framework. It's for creating powerful and scalable native mobile apps in .NET and Azure. And yeah, so that is the developer and mobile tools for Azure. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure DevOps services. So Azure DevOps is really just an umbrella service for a bunch of modern dev services, and we'll jump into them right away. First being Azure Boards. If you've ever used a Kanban board, that is what Azure Boards is. And if you've ever used GitHub Projects, it literally is that, because Azure and GitHub are owned by the same company, Microsoft, and so they brought over that technology to Azure. So deliver value to your users faster using proven agile tools to plan, track, and discuss work across your teams. Then you have Azure Pipelines, so build, test, and deploy CI/CD that works with any language, platform, and cloud. Connect to GitHub or any other Git provider and deploy continuously. So if you need automatic deployments, that's what Azure Pipelines is for. Then you have Azure Repos, and this is exactly like GitHub Repos. So get unlimited cloud-hosted private Git repos and collaborate to build better code with pull requests and advanced file management. And I really mean it's just like GitHub Repos, because it's just that technology moved over to Azure. Then you have Azure Test Plans, so test and ship with confidence using manual and exploratory testing tools. So this is just a way of setting up tests. So if you ever use like what's it called, Cypress or any other testing tools, it's just built into Azure. It'll open up a browser and it'll literally test your application and make sure it works as expected. Then you have Azure Artifacts, so create, host, and share packages with your team. So this is just package management, but specifically for CI/CD pipelines. So CI/CD pipelines, they have to set up these servers, and you have to have pre-installed packages. That's just going to make it a lot easier for you. Last is Azure Dev Test Labs. So this is just an easy way to create dev test environments for your developers, and that is the Azure DevOps services. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Resource Manager. And just to understand the service, we need to understand what infrastructure as code is. So also abbreviated as IAC. This is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configurations or interactive configuration tools. If that is complicated, all it means is that we're using scripts. We're using scripts to set up services like VMs or databases or storage, so that you don't have to manually go through the interface, or you can give that script to another team or company, and they can set up the exact same setup you have within seconds. So the infrastructure as code service for Azure is called Azure's Resource Manager, or ARM for short. It allows you to programmatically create Azure resources via a JSON template. I'm just going to show you what that template looks like. So you would make this template and it will allow you to launch a virtual machine. Okay, so instead of going through the interface and clicking and doing a bunch of stuff, you just define all the stuff you want to do in JSON. This is a very short version of it. There's definitely a lot more configuration that would be required. But here, this would be a very easy way to set up a virtual machine using code. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Quick Start Templates. So Azure Quick Start Templates is a library of pre-made ARM templates provided by the community and partners to help you quickly launch new projects for a variety of stack scenarios. So in the last slide, we just talked about Azure Resource Manager, where it's just a template to, or a JSON file to quickly set up resources. Well, that is taking that file and just sharing it with other people, right? But it's shared through actual vendors, okay? So you could go to the Azure Quick Start and let's say you wanted to deploy a Django app. And I think it's like also it's vendors and also community contributed scripts. So if you want to deploy a Django app, you could use that Quick Start. If you wanted to deploy Ubuntu with a Docker engine, you could use that script. If you wanted a CI/CD containerized app with Docker Enterprise Jenkins, you could use that script. And if you wanted a web app that was running Linux with Postgres, you could use that script. So it's just a quick way of getting started. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Virtual Networks, also known as VNet, and the concept of subnets. So a virtual network, and as we said, it stands for VNet, is a logically isolated section of the Azure network where you launch your Azure resources. And when you create a virtual network, you have to define a certain amount of IP addresses that you're going to use, which we call a CIDR range. We'll come back to that in a moment. But here is a graphical representation of your VNet. So here we have the Azure network, and then within that we have a region, so US East 1, and then we would create our virtual network so that we can launch our Azure resources within. And in there we have two subnets, a public one, a private one, and then in the public one we have a virtual machine, in the private one we have a database, and in the public one it's actually it can actually have access to the internet, whereas the private one it does not. So not all services require a VNet, but most do. So because you just have to put your resources somewhere, and they have to go into a virtual network, which are associated with an IP address, whether it's public or private. Then there's other network controls that are involved. So now let's take a look at the CIDR range. So CIDR range, I said, is just an allocation of IP addresses that you are going to use in your virtual network. And all I want you to know is that, see where it says 10.0.0.0, that's the name of our network, but we have that /16, that is the CIDR range. And the lower the number, the more IP addresses you get. I'm not going to get into the math in this video, it's not necessary, but just understand that /16 is a very big number. And that's the amount of IP addresses that we can launch. So we could essentially launch 65,000 servers within this virtual network. And so we can subdivide our virtual network into subnets. So it's a logical partition of an IP network into smaller network segments. So that's what you're doing. You're breaking up it into smaller IP ranges. And when you create a subnet, they have to be smaller. So you have to define a CIDR range for those as well, but they have to be smaller than the VNet. Remember I said the higher the number, the lower it is. So when you have /24, that's just saying 256 IP addresses. All right. One more thing is I want to note is that we have things called public subnets and private subnets. So public subnets reach the internet, private subnets do not. So when you have sensitive things like your database, you don't want that to be in a public subnet, but a web app, which generally has traffic coming from it from the internet, that's okay, all right? And that's all we need to know here. Hey, this is Andrew Brown from Exam Pro, and we are looking at the cloud native networking services. Now, these networking services aren't super important for the exam, but I like to go through them. Generally, I would make an architectural diagram for this, but it's just a bit too complicated, so I thought we'll just go through and list them. So first is Azure DNS, and we do describe this service later in the course here, but this provides an ultra-fast DNS responses and ultra-high domain availability. So if you have a domain name and you just want it to be managed by Azure, you can associate it with Azure DNS. Then you have Azure Virtual Network. We talked about this prior, but we'll talk about it again. Short for VNet, a logical isolated section of your Azure network for customers to launch Azure resources within. Then you have Azure Load Balancer, and as the name implies, it is a load balancer, but this one is at level 4 transport. So it doesn't really understand requests like what a web application would send. It's more lower level. And so that's what that is. Then you have Azure Application Gateway, and this is an HTTP load balancer, so it does understand like requests coming from a web server. And what you can do with it is you can actually route based on HTTP requests to specific services, but it also you can apply a web application firewall because it is an application load balancer. That's why you can apply that web application firewall, which is a separate service. Then you have network security groups. So this is a way of protecting your subnets. So it's a virtual firewall around your subnets where you can say, allow these ports to be open, and from who and such. So there you go. That's the cloud native networking services. And the reason why they're cloud native networking is because you wouldn't use these with enterprise or on or in hybrid models. It's just what you normally use. And most startups would be using all these these networking services. So next we have enterprise or hybrid networking services. So this is when you're using networking that is going to bridge on-prem to the cloud. So the first is Azure Front Door. So this is a scalable and secure entry point for fast delivery of your global applications. So it's just making sure you have a secure entry point into Azure from outside. Then you have Azure Express Route. You want to remember this one definitely for the exam. It probably will show up as a question. This is a connection between your on-premise to Azure cloud, and it can be between 50 megabytes per second to 10 gigabytes per second. I'm pretty sure it's also secure. But the point is that if you need a super fast connection from your on-prem data center to Azure, you'd use this service, Express Route. Remember it. It's going to be on your exam. Then you have Virtual WAN, so a network service that brings many networking security routing functionality together to provide a single operational interface. I know that sounds complicated, but a WAN is just a way of making networking easier by creating like a hub-spoke model. Then you have Azure Connection. So a VPN connection securely connects to Azure local networks via IPsec. So that's just a way of creating a secure connection with Azure. Then you have Virtual Network Gateway, a site-to-site VPN connection between Azure Virtual Network and your local network. So this is just a way of connecting with Azure. So there you go. That is the networking services. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Traffic Manager. So this service operates at the DNS layer to quickly and efficiently direct incoming DNS requests based on the routing method of your choice. So what you do is you'd choose a routing method. So we got performance weighted priority, geographic, multi-value, subnet, and you'd be able to reroute your traffic. So you could route traffic to servers geographically nearby to reduce latency, fail over to redundant systems in case primary systems become unhealthy, or route to random virtual machines to simulate A/B testing. I think like the best use case is failovers at the DNS level. I think that's a great one. And just a visual example here, imagine we had exampro.co and we had a production server and a beta server, and we only wanted 20% of our users to see the beta server. So we could use I guess we'd use weighted there, and we'd say 80% on prod, 20% there, and that's how that would work. So there you go. That's Azure Traffic Manager. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure DNS. I told you we would come back to this one because we're on the networking slides. I just did not describe this in detail. So Azure DNS allows you to host your domain names on Azure. You can create DNS zones and manage your DNS records. So if you wanted to add a record, like let's say we had exampro.co and it was being managed by Azure DNS, we could add beta as a subdomain, and we could use alias to route that to a load balancer or virtual machine, and then that would go into our list of records. One thing that is interesting, and it's kind of a downer, which is Azure DNS does not allow you to purchase domains. So it only gives you the ability to manage DNS records. Some other cloud providers, they allow you to purchase and manage, but only Azure DNS does not at this time, maybe in the future. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Load Balancer. We had only mentioned this briefly in the networking services slide, and so we'll look at it more here. So Azure Load Balancer is used for evenly distributing incoming network traffic across a group of backend resources or servers. Azure Load Balancer operates on the OSI layer 4. That's the transport layer. So it doesn't understand HTTP requests. It's just sending packets back and forth. So here is a graphical representation. So imagine you have the internet and somehow it's making its way to the load balancer. What the load balancer is going to do is it's going to distribute that amongst your virtual machines. Virtual machines being your servers. And the great thing is that you can have virtual machines in different availability zones, and the load balancer can distribute it to those. And that's how we get high availability, okay? And now with Azure Load Balancer, you can create both a public load balancer, so that's incoming traffic from the internet, to public-facing servers, so servers that have a public IP address, with internal, or an easier way to describe it would be a private load balancer. So incoming internal network traffic to private-facing servers, so private IP addresses. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at scale sets. And so this allows you to group identical virtual machines and automatically increase or decrease the amount of servers based on the change in CPU, memory, disk, network performance, or on a predefined schedule. So when we talk about elasticity, we're talking about using scale sets, the ability to automatically increase or decrease the amount of servers. So here is a visual representation. Imagine you have internet traffic and it hits that load balancer, and then we determine that the current load on the existing server is greater than 80% CPU utilization. It's going to need some extra servers. And so what happens is the scale set decides, okay, we're going to have to add 1 or 2 more servers. And when that CPU usage goes below 80%, then it says, okay, we don't need those servers anymore, get rid of them, okay? So that is scale sets. Hey, this is Andrew Brown from Exam Pro, and we are looking at IoT services on Azure. And so before we get into it, what is IoT? So IoT stands for Internet of Things. So a network of internet connected objects, usually hardware, able to connect and exchange data. So here is a graphical representation of IoT devices. Maybe you recognize some, but let's just go through a quick list of things that could be IoT devices. So you have smart bulbs. So maybe there's light bulbs in your house that are controlled by the internet. Smart fridges, who doesn't want one of those? Smart light switches, narrowband or wideband hardware. This is just a way of connecting to the internet. It's just like, it's kind of like Wi-Fi. Then you have security cameras. Then you have voice command speakers. So think of like Alexa. Then you might have temperature, pressure, or humidity sensors. If you're in the farming industry, you can leverage IoT devices for that. Maybe you have drones. Maybe you have phones, that could be an IoT device, and even buttons. So AWS had these things called AWS or dash buttons. They weren't popular, but the idea was you could like press a button and like purchase something. So like if you always had to get like soap for your washer, you could have that button right on your washer. But let's actually talk about the IoT services here. So the first one here is IoT Central. So this allows you to connect your IoT devices to the cloud. Then you have IoT Hub. So this enables highly secure and reliable communications between your IoT applications and devices it manages. Then you have IoT Edge. This is a fully managed service built on the Azure IoT Hub. It allows data processing and analysts near the IoT devices. So this is really edge computing. I really should have highlighted that for you, but this is where you are able to offload your compute from the cloud to local computing hardware such as IoT devices, phones, or home computers. So it's just a way of saving money or utilizing your local network for compute. Then you have Windows 10 IoT Core Services. So this is a cloud services subscription that provides the essential services needed to commercialize a device on Windows IoT or 10 IoT Core. So basically it's long-term OS support and services to manage device updates and assess device health. All right, so there you go. That's your IoT services. Hey, this is Andrew Brown from Exam Pro, and we are looking at big data and analytics services on Azure. So before we jump into it, let's talk about what is big data. So it is a term used to describe massive volumes of structured and unstructured data that is so large it is difficult to move and process using traditional database and software techniques. So we need special services just to handle them. The first on our list here is Azure Synapse Analytics, formerly known as SQL Data Warehouse. So it is enterprise data warehousing and big data analytics. So it's intended to run SQL queries against large databases to generate things such as reporting. Then you have HD Insight. HD is short for Hadoop. But anyway, it runs open source analytics software such as Hadoop, Kafka, and Spark. I imagine it was called HD Insight because it only supported Hadoop and then they added additional services, but that's just what it's called. Then you have Azure Databricks. So we have an Apache Spark-based analytics platform optimized for Microsoft Azure cloud service platforms. So third-party Databricks cloud services supported with Azure. So Databricks was made by the creators of Spark. And yes, of course, you can run Spark on HD Insight, but Databricks is its own cloud service provider, and Azure partnered up with them so that you can use it within the Azure platform. Then you have Data Lake Analytics, so an on-demand analytics job service that simplifies big data. And we saw what data lakes were when we looked at storage services, but we'll describe them here just in a little bit different way. A data lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So there you go. That is the big data and analytics services we need to know. Hey, this is Andrew Brown from Exam Pro, and we are looking at artificial intelligence and machine learning services on Azure. So a great way of describing that is to always have this graphic here where we have this kind of like onion thing where each is dependent on the other. And we'll start with artificial intelligence. So what is artificial intelligence or AI? This is where machines that perform jobs that mimic human behavior. Now, that doesn't mean that the technology behind it has to be complex. It could be if-else statements, but it could be utilizing machine learning. It could be utilizing deep learning. But the point is that it mimics human behavior. Then you have machine learning, and this is where machines that get better at a task without explicit programming. So they are smart enough to learn on their own. Then you have deep learning. And so deep learning is where machines that have an artificial neural network inspired by the human brain to solve complex problems. So literally it's like the power of the human brain, maybe not as great as the human brain, but quite close there. And AI could be leveraging ML and deep learning. And so that's why it is like that. So when we want to do machine learning on Azure, they have a service called Azure Machine Learning Service. So this is a service that simplifies running AI, ML-related workloads, allowing you to build flexible pipelines to automate workflows. So you can use Python and R. You can run your deep learning workloads using technologies such as TensorFlow. And so that's what you'd use. Now, there was a service called Azure Machine Learning Studio. I think it's still around if you're still using it. And that's the classic version of the service. And it does basically what Azure Machine Learning Service does, but there's some limitations. So it does not have pipeline and other functionalities. And if you're wondering if you could easily migrate from Classic to the other one, it's not easy to migrate. So basically, you definitely always want to start with Azure Machine Learning Service. There's no reason you'd want to use Azure Machine Learning Studio unless you're using it for legacy reasons. Hey, this is Andrew Brown from Exam Pro, and we're still looking at AI and ML services, specifically just AI services, because Azure has a lot of them, and I'm just going to quickly go through them, and they're pretty self-explanatory. So the first one is Personalizer. It delivers rich, personalized experiences for every user using AI. Then you have Translator. It adds real-time multi-language text translation to your apps, websites, and tools. You have Anomaly Detector, detects anomalies in data to quickly identify and troubleshoot issues. Azure Bot Service, intelligent serverless bot service that scales on demand. Form Recognizer, automate the extraction of text, key value pairs, and tables from your documents. You have computer vision, easily customize computer vision models for unique use cases. Language understanding, so build a natural language understanding into apps, bots, and IoT devices. We have Q&A Maker, so create a conversational question and answer bot from your existing content. Text analytics, extract information such as sentiment, key phrases, named entities, and languages from your text. Content moderator, so moderate text and images to provide a safer, more positive user experience. Face, so detect and identify people and emotions in images. Ink Recognizer, recognize digital ink content and such as handwriting, shapes, and document layouts. So there you go. They have a lot of services, and they haven't even made time to make all icons for them. That's how many they have. Hey, this is Andrew Brown from Exam Pro, and we are looking at serverless services on Azure. So what is serverless? This is when the underlying server's infrastructure and OS is taken care of by the cloud service provider. It will generally be highly available, scalable, and cost-effective. So serverless is event-driven at scale. So a serverless function can be triggered or trigger other events, allowing you to compose complex application and just scale. So with serverless technology, it's like playing with Lego blocks. Then you have abstraction of servers. So servers are abstracted away. Your code is described as functions. These functions can be running on different compute instances. So if some people like to use Python or some people like to use JavaScript, you can mix and match there. Then you have micro billing. So when you have traditional servers, you'd probably be billed by at least a second. Some bill by the hour. But the thing is, if you're not using the server for the whole second or hour, you are paying for compute that you are not using. So serverless functions will bill you in the microseconds, so you're saving money because you're not paying for unused computation. Now we'll just quickly walk through some of the serverless services. I'm sure there's more than this, but this is what I think are worth highlighting. So the first is Azure Functions. So run small amounts of code known as serverless functions in your favorite languages. So you got C#, Java, JavaScript, Python, and PowerShell. And if Azure is listening, please can you support Ruby, because I love using Ruby. Then you have blob storage. So this is serverless object storage. Just upload your files. Don't think about the underlying file systems resizing, basically unlimited space, and you can upload pretty darn large files. Then you have Logic Apps. Allows you to build serverless workflows composed of Azure functions, building I would say this is you building a state machine for serverless compute. Then you have Event Bridge, which seems a bit similar, but it's not. It uses pub/sub messaging systems to allow you to react to events and trigger other Azure cloud services such as Azure Functions. So there you go. That is serverless services. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Portal. So the Azure Portal is a web-based unified console that provides an alternative to command line tools. You can manage your Azure subscription with the Azure Portal, build, manage, monitor everything from simple web apps to complex cloud deployments. So what does that mean? It just means the browser that you use to access Azure. So anytime you're logged into Azure, that is the portal. That's all you need to know. There's another thing about Azure Portal, and that's Azure Preview Portal. So the thing is that sometimes there are new features or new products that Azure has made that are not necessarily generally available, but you can get a sneak peek of them sooner if you use the Azure Preview Portal. So that could be previews, betas, or other pre-releases. So the way you would do that is very similar how you'd access the regular portal. But if you want a test preview of new features, you go to the preview.portal.azure.com. Or if you're looking for stable release and production ready features, you just use portal.azure.com. So that's all you need to know about the Azure portal. So I just wanted to quickly show you what the portal looks like. We are going to show you in this course how to create your own account and work within the portal. But I already have one set up here, and I'm already logged in. And if I go to the top here, I actually have this portal link now. And when I go here, we can see what the portal looks like. So this is the portal. You can see that it's telling me about my spend, but I'm on the dashboard right now. On the left-hand side, we have this hamburger menu where we can explore the services. We can go up here and search them as well. So whatever I'm looking for, if it's monitor, we can go there. And that's pretty much it. This is the portal. So it's just the browser when you're logged in, and you can interact with any cloud resources. Hey, this is Andrew Brown from Exam Pro, and we are looking at PowerShell for Azure. So first of all, what is PowerShell? So PowerShell is a task automation and configuration management tool, but an easier way to think of it is it's a command line shell, and it's also a scripting language. And so when I say a command line shell, I mean this blue thing. And so if you have a Windows machine, you'd have to, I think, have Windows Professional, but you can go ahead and install this, and it allows you to automate things using its scripting language as well as in this program. Now, PowerShell is available on Azure as well, and we'll get to that in a moment. But let's just talk about the benefits of PowerShell over traditional shells. So a shell could be something like Bash or ZSH, which would accept and return text. But PowerShell is built on top of the .NET Common Language Runtime, so CLR, and it accepts and returns .NET objects. So those objects make it a lot easier to automate scripting. And so PowerShell is available on Azure, and it's known as Azure PowerShell. And so we have a set of commandlets for managing Azure resources directly from the PowerShell command line. And if you're wondering how you'd access PowerShell, you could use Cloud Shell, which we'll talk about here in a moment. Okay, so I just wanted to quickly show you PowerShell. I'm on my Windows computer right now, and this is natively installed on my Windows 10 computer. And I can type in commands here, and so this is just giving me a list of all my the directories in this current folder. But I just also want to show you that we have PowerShell here in the Azure portal. So I'm using the Cloud Shell up here, and I've chosen to use PowerShell, and you can see it's pretty much the same experience with some extra things that make it easier to work on cloud. So that's it. Hey, this is Andrew Brown from Exam Pro, and we're looking at Visual Studio Code. So Visual Studio Code is a free source code editor, meaning it edits code, made by Microsoft for Windows, Linux, and Mac OS, and you can even run it in the cloud. And if you're wondering what it looks like, this is the editor. And this is not to be confused with Visual Studio. So Visual Studio is an IDE, and it is also for programming, but it has a lot of functionality built in here. Is Visual Studio Code open source? Well, they say that it is, but I don't know to what degree. I don't know if it's 100% open source, but this is the most popular text editor or code editor out right now. And Azure has a service called, it's like Visual Studio Workspaces that's on Azure, and it allows you to spin up these developer environments using this editor right in the cloud. I don't think it's going to be on your exam, but I just thought it was cool to mention. And if you don't have a code editor, I strongly recommend downloading this one for your computer because it is great. So I just wanted to quickly show off Visual Studio Code here. So if you wanted to go download it yourself, you just type in Visual Studio Code into Google, and you should end up here, and you can download a version. It's for Windows, Mac, and Linux, so you can download for anything, and you can run it in the cloud on Azure, or even launch your own server on other cloud providers. I just happen to have Visual Studio Code open here with an open source project, just to show you what it looks like. The thing that people really like about it is just it looks great, and it has really good plugins. So if I just go to extensions here, anything you need, you can add it and enhance this editor here. If you don't have a code editor, I strongly recommend downloading this, and I just wanted to make you familiar with this editor here. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Cloud Shell. So Azure Cloud Shell is an interactive, authenticated, browser-accessible shell for managing Azure resources. And so it provides the flexibility of choosing the shell experience that best suits the way you work. So you can either use Bash or PowerShell. We just talked about PowerShell, and this is the place where you could use it in Azure. So just to give you a visual, if you ever want to access the Cloud Shell, it's all the way up in the header there in the portal. And so you click that button, it opens up PowerShell, or it will depend on what you choose, but it will open it up down below. And then you'll be able to use PowerShell right away, and also the CLI right away, which we'll talk about next, is the Azure CLI. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure CLI. So What is a CLI? Well, CLI stands for Command Line Interface, and it processes commands to a computer program in the form of lines of text. And the operating system implements a command line interface in a shell or terminal. So we saw a shell earlier, which was PowerShell, but we'll look at what CLI commands look like here in a moment. So the Azure CLI can be installed on Windows, Mac, and Linux. Once it's installed, you would type AZ followed by other commands to create, update, delete, view, and manage your Azure resources. And so to really show you what that code looks like, down below we have a bash script, but this could easily be PowerShell. And you have the commands AZ, and then you would have what it is that you want to do. So if you wanted to create a group, you type AZ group, create, and you provide the name and the location. Or let's say you wanted to launch a virtual machine, which is a server, you do AZVM, create, and then provide those other parameters. So that is how you would programmatically create Azure resources, and there's tons and tons of CLI commands for Azure. So you basically, anything you're looking at pretty much can be created with the CLI programmatically. Hey, this is Andrew Brown from Exam Pro, and I'm going to show you how to create resource groups. And the reason why we're going to make one is because without one, we're not going to be able to launch pretty much any resource until we do so, because you always have to choose a resource group when launching Azure resources. So even though it shows up here on our dashboard, if it doesn't, I want you to go up here at the top and type in resource group. And we'll go ahead and click resource group here. And then all the way on the left-hand side, I want you to click on add. And we're just going to have to use our free trial, which is our type of subscription. I'm just going to type in Exam Pro as the resource group. We're going to stay in US East because that is where the most of the services are available in Azure, and that's what I'm going to be using throughout this course, is always using US East. So we'll go down here and hit create plus review plus create, because there's really nothing else to check. And once validation passed, this might happen instantaneously for you. You might have to wait a few seconds. Go ahead and hit create. And so now we have created our resource group. And there is no cost to resource groups, so there's no worry about having this or whether you keep it around and don't delete it. You're going to notice that the group hasn't showed up just yet. You're going to have to hit refresh. And sometimes Azure is a bit slow about showing resources when you create them initially and when you delete them. So I'm just going to wait a little bit here, and I'm just going to keep on refreshing, and I'll see you back in a few minutes. All right, so I waited a couple minutes, and if you just go ahead up here and hit refresh, now we can see that we have our resource group. So that's all there really is to it. Nothing super exciting there. I'm just going to click Microsoft Azure at the top here to get back to my dashboard, and I'll see you in the next follow along. Hey, this is Andrew Brown from Exam Pro, and we're going to look at making our own virtual network. So we made a resource group, but we also need a virtual network or VNet, so we actually have some network to launch our resources within. So what I want you to do is make your way all the way to the top here, and we're going to go ahead and type in VNet, which will get virtual networks, and go ahead and click that. And if you notice, you don't have any networks, so we're going to have to go ahead and create our own. So go ahead and hit the add button. And we're going to have a bunch of options here. I'm just going to name this, we're going to choose that resource group, so Exam Pro. And we're just going to name this Exam Pro VNet. And there are some additional steps here. We'll just take a peek here. We don't really need to change anything, but we'll just take a look. So for IP address, you can set the IP address space. It's going to default to 10.0.0/16, which is very good for us. You can see that it supports IPv6, which is great. It's going to create us a default subnet, which is going to be 10.0.0/24. That's going to be a subnet with like 256 IP addresses, which is great. If we go to the security tab, we have DDoS protection basic, and you definitely want to stay on that because that is free. Same thing with the firewall. We don't want it on because that's going to cost extra money. I'm going to go back to basics. We're going to hit review plus create. And we're just going to wait for validation to complete. This could be instantaneous for you, or you could wait a few seconds. It's different for everybody. And now the validation has completed. We'll go ahead and hit create. And so we'll just wait for that to finish creating. Great, so it's created, so it's just saying deployment is underway. So we're just gonna have to wait a little bit here until it says deployment is complete, and it's already done super fast. And we'll go ahead and hit go to resource. And so now we are in our virtual network, and we have a bunch of settings on the left-hand side. So address space, subnets, et cetera, et cetera. Nothing we need to know at this level. We just need that virtual network so we can launch resources in. So now that we have resource groups and virtual networks, we can start launching resources. So there you go. I'll see you in the next follow along. Hey, this is Andrew Brown from Exam Pro, and I'm going to show you how to launch your own server on Azure. And so a server would be considered some kind of computing service, and the one we're going to do right now is we're going to use virtual machines. So go all the way to the top here to search, and I want you to type in virtual machine. I know it's on our dashboard here, but just to get in the habit of always being able to find stuff, it's great to use the search. And then once we're here on the left-hand side, I want you to click Add. And we're going to be presented with a lot of different options. So the first thing we need to do is choose our resource group. We have another resource group that was created here for us for Azure. I wouldn't worry about it. Let's just choose the one that we created. I'm going to name this virtual machine. I'm going to call it my VM. We're going to launch it in US East. If we wanted to choose an AZ, we could. So we go to availability zone and choose one. I'm just going to stick to no infrastructure. Then we have Ubuntu here. It's using the latest version. It might be different for you. I wouldn't worry too much about it. Then we need to choose our size. This is going to really determine our cost. Here, this is $89 Canadian. I'm just going to go ahead and hit select here. And we're just going to sort on the right-hand side based on cost. And we're going to choose the most inexpensive server, which is the B1LS. So that's 1 vPCU and half a gigabyte of RAM. Because this is just an example app, we're not going to do any, or a server, we're not going to do anything with it. So we might as well make sure we're not overspending our free credits. We have the option to add a public key. This is what you generally would want to do, but that's a lot of work. And so for this demo, so we're just going to choose password. They're very finicky about the passwords here. That it has to have a uppercase, lowercase, special character, number, and it also has to be 12 characters. So I'm going to type in testing with a capital T, testing, 1, 2, 3, exclamation, exclamation, and then testing with a capital on the T, 1, 2, 3, exclamation, exclamation. So there we go. We don't need any inbound ports. I'm going to say none because we're not SSHing in. I'm just going to click forward here to show you some of the other options. So we could choose the type of disk we'd be attaching. So it's by default on premium. You might want to choose standard or standard HDD. Generally, when you're launching web apps, you want SSD. If we were to choose standard, it would say, hey, you should really use premium. So we're just going to go back to premium. You're going to notice that the disk is encrypted by default, so you can't have an unencrypted disk. That's a very good default option. If we go over to networking, it's going to automatically select our VNet that we chose and the default subnet that it created when we created the VNet. And then here we could choose whether we want an IP address or not. If it had no public IP address, it would still have a private IP address, and that would mean that it's really intended for a private subnet. It has a network security group set onto basic here. And that's pretty much it here. You could also put it behind a load balancer. We're not going to do that. Let's go over to management. Management, we have a couple options here, like identity, auto shutdown, backup. These are all fine. We're just going to leave it alone. For advanced, we could put custom data in here. That means we could provide it a script that it would use to initially set up the server. We're not going to do that. And that's about it. So I'm going to go back to basic, and I'm going to scroll all the way down to the bottom, and I'm going to hit review plus create. And what we're going to have to do is wait for this validation step. That was very fast. It might take multiple seconds for you or even a minute, but sometimes it's faster than others. So now I'm going to go down below and hit create. And we're just going to wait for that deployment to be submitted. It's going to say deployment is underway, and then soon it's going to say deployment is complete. So I'll see you back here in a moment when deployment is complete. Great, so we had to wait a few minutes there, and now it says deployment is complete, and we can proceed to go to resource. And so here's our virtual machine. We have some CPU, some network, some disk, so there's some activity here. If we wanted to gain access to it, there should be a connect button here. We're not going to be able to gain access to it because we just didn't set it up in a way that was the case. We have a few options down the left-hand side, such as the disks that are actually attached to it, and maybe the size here. So maybe if we wanted to resize, change it to a larger size, we could go ahead and do that. But there's nothing really exciting here to do. I just wanted to show you how to launch your own virtual machine. And now that we have our own virtual machine launched, I'm going to go back to overview. We're going to go ahead and delete that because this is now costing us money. It's not costing us a lot of money, but again, we're done here. So we'll just go ahead and delete. We're going to say yes to delete. And now it says it's deleting the virtual machine. And so we're just going to wait until this is finished deleting. And a lot of times you can just look at the progress up here and it'll say deleting the virtual machine. Could take a few seconds. It could take a few minutes. It just depends. So I'll see you here in a little bit when this is done deleting. So after waiting a little while here, it says it's now successfully deleted the virtual machine. If we want to make sure that it's deleted, let's go make our way over to virtual machines at the top here in the search. And you're going to notice that it's still showing up there, but it said it was deleted. And this is the thing with Azure is that it takes time for it to propagate. So what we'll have to do is just hit refresh, and now it's gone. So just be aware that sometimes the consistency in terms of what you see in the UI is a bit delayed. And so if you remember clicking delete and it says that it deleted it, just have a bit of patience there and hit refresh and just double check to make sure that's the case. So there you go. Okay, great. So now that we've done that, let's actually go learn how to do a different kind of compute, which is serverless functions. So if we want to launch our own serverless function, by the way, if you're not at the screen, just click on Microsoft Azure here at the top. And we're going to go to our search and we're going to type in functions. And so on the left-hand side, I want you to click on add. And then what we're doing is we need to create a function app. So we're going to be on our free trial. We're going to choose our resource group we created earlier. We're going to name this. I'm going to just call this, this is the function app name. So I'm going to just say my app. My app is not available. These are all unique names. I'm just call it Exam Pro app. You might have to change this a few times before you get what you want. And then for publish, we're going to use code. We don't want to use a Docker container. That's too much work. And we're going to just choose Node.js, which is just JavaScript. Version 12 sounds great to me. We're going to change this to make it sure that it's US East to make our lives a little bit easier. There's nothing wrong with Central. It's just I want everything to be consistent, so everything's very predictable in these follow-alongs here. We'll go all the way to the top and look at hosting just quickly here. We're going to see that we have a storage account. Okay, nothing exciting here. It's going to either be Linux or Windows. This doesn't really matter to us. We can let it be Windows. We're going to go back to basic. I'm going to go ahead and hit review plus create. So we're going to wait for this validation step to complete here. So again, it could take a second or it could take a minute. It just depends on the day with Azure. So we'll just wait here a little bit. There we go. It's just finished validating. I'm going to go ahead and hit create. And now we're waiting for that initial deployment. So we're going to see that deployment is on its way. And then we're going to have to wait for deployment to be complete. So it's in progress, it's underway. This shouldn't take too long. It should say that it's complete here in a moment. Great, so after waiting a few minutes here, our deployment is complete. We'll go ahead and hit go to resources. So now what we need to do is we need to go create ourselves a function. So on the left-hand side, make your way to functions. And then in here, we're going to add ourselves a new function. And so we have a lot of presets here for us. It's not going to matter what we choose. Well, it does. And I'm going to say, let's choose HTTP trigger. We're going to leave it with the default name. That's fine. We'll have it stay as function for authorization level. We'll go ahead and create that function. So once that function has been created here and it's already done, let's start adding our code, because again, the whole point of serverless is that you don't have to worry about servers. You just add your code and it works. And so here's some code it already has for us. What I'm going to do is I'm just going to add myself a console log. Console log is just like saying hello world. So we're going to say hello world. And then I'm going to hit save. And now it's just connecting to application insights. I don't know if it's actually running it. Yeah, it's connected. Great. And now let's go ahead and hit test. And so we have a bunch of options here. I'm not going to fill in anything. I'm just going to hit run. And we're going to see what the output is. Okay, great. So, I'm just looking at how this actually works. And I think what we need to do is we need to actually pass a name into the query string here. So what we'll do is we're just going to go ahead and type in query here, and we'll put a name, and we'll say Andrew. And so that should do it. So let's just hit run. Okay, great. And so it's saying, hello, Andrew. So there you go. That's all you have to do to create a serverless function. And it doesn't cost us anything to keep this around, so we don't necessarily have to delete it. If you did want to go delete it, I guess we could go back here. We'd have to go back to functions here. And I would just click delete. And we'll type in yes. And we'll hit delete. And there you go. So that's all there is there to it for serverless compute. I can go back to Microsoft Azure here, back to the dashboard, and we'll see you in the next follow along. Hey, this is Andrew Brown, and in this video, I'm going to show you how to set up blob storage. And so if you remember through the actual course, blob storage is like serverless storage, so you don't have to worry about running out of space or resizing your disk. So let's go to it. At the top here, I want you to type in blob storage, and you're going to go to storage accounts. And this is where you end up creating all of your storage accounts. You can see that we have a couple of storage devices from the virtual machine and when we created the serverless function there. So go ahead and hit add. And what we're going to do is choose Exam Pro or whatever you called yours when we were at the resource group step. Then we're going to have a storage device. I'm going to say my blob storage. Oh, it has to be all lowercase. My blob storage. And that's already taken. So we'll say Exam Pro blob storage. And it can't have hyphens. There we go. And so we're going to launch it in US East. We have the difference between standard and premium. I think we'll stick with standard. We have storage type V2 or V1 or blob storage. We want blob storage. We have some replication options here. I'm just going to leave it alone. We have access here, hot or cool. We're just going to leave it hot. And we can just look at networking here for a moment. We're going to leave this alone. We're just going to look at advanced in a moment. So nothing exciting there. We'll go back to basic, hit review plus create. We'll have to wait for validation. We'll go ahead and now hit create. And then it should say deployment underway. We're waiting to see this say deployment complete. You might be getting into the rhythm of how creating services now. It's almost always the same process. And we'll just wait here till this is complete. Okay, great. So I just waited a minute there and now that's all set up. So let's go ahead and hit go to resource. And then we have a lot of stuff around here. So what we want to do is we want to start uploading files, but I think we have to create a container first. So go all the way down here, left-hand side, and go to containers. Then we're going to create a new container. I'm going to call this Star Trek. It's going to be a private container, so it's only just for me. We'll hit create. And now we should be able to click into that container. All right, so now now that we have that container, what we can do is go ahead and upload our first file. I just happen to have a file on my desktop here. So I'm just gonna go select that there and upload. All the options by default are great here. We'll just hit upload. And there we go. So we just uploaded a file into our blob storage. Yeah, so that's all there really is to it. So now that we're all done there, we can just go ahead and delete this container. So I think we'll just go back to storage accounts. Not sure if we have to delete the containers first. I guess we'll find out. And we'll just go here to blob storage. We'll go ahead and hit delete. And we'll hit yes. And we'll go to delete. And there you go. So we'll just go back to Microsoft Azure there, back on our desktop, and I'll see you in the next follow along. Hey, this is Andrew Brown from Exam Pro, and I'm going to show you how to use Cloud Shell. So if you want to, it actually doesn't matter where you are because Cloud Shell is accessible anywhere when you're in the Azure portal. It's actually this icon up here. So what I want you to do is go ahead and click that. And what it's going to do is ask you whether you want Bash or PowerShell. I'm going to choose PowerShell. We're going to use our free tier, and we're going to need to create some storage with it. I'm just going to drag that up there a bit. So we'll just wait for it to create that storage device. And so now we get this blue screen, which is very typical of PowerShell. And so it's going to have to initialize our account. So we're just going to have to wait here a little bit until that's done. Great, and so now we have our Cloud Shell. And so one of the advantages of having a Cloud Shell is that if you want to do the CLI and start doing things programmatically within Azure, you can do that very easily here. So we already have the CLI installed, so we can just type in AZ. Whoops, let's type in clear here. AZ account list. And there you go. So we got some account information back there. So that's all I wanted to show you for PowerShell. We can go ahead here, and I think we can just power it off. Or that would restart it. We just hit X. And there you go. That's it. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Trust Center. So all it is, it's a public-facing website portal providing easy access to privacy, security, and regulatory compliance information. So there it is. That is the portal. If you type in Azure Trust Center, that's the way you get to it. And the idea here is that, whatever information your organization needs, it's just all public-facing. So you don't even have to log in to get access to it, but it just helps you make security decisions for your company. All right, so I just went ahead there and went to Google and typed in Microsoft Trust Center. And so this is the page here. So if we just scroll on down here a little bit, we'll see that we have Microsoft Azure. And here we have a bunch of options where we can read about their security, privacy, and compliance. Let's go into compliance for Azure. And here we can see a list of a bunch of compliance programs that Azure is meeting. So we have a ton here. So if we went into GDPR, it might ask us to sign in. So I'll just hit Andrew and Canada. And I agree. Okay. And so now I can read all about GDPR. So it gives me a lot of detailed information about this compliance program and how it applies to Azure. So there's a lot of interesting stuff here. I'll just go back here. We can click on security. And so there's just some generalized information here. But generally what you're looking for when you are coming to here is really this compliance programs. This is what everybody's always looking for, is to read about that stuff in detail. And so that's all you have to do to get there. So yeah, there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at compliance programs for Azure. So enterprise companies will not buy your software solutions unless they are secure. And so how would you go about meeting their security compliance requirements? And that's where compliance programs come into play. So basically, an enterprise company is going to say to you, we'll only do business with you if you are NIST compliant, or if you are PIPEDA compliant, or if you are HIPAA compliant, or if you are FIPS 140-2 compliant. You might say, well, that's a lot of stuff, but after a while, you just start to remember them. But at first, it is extremely daunting, but I thought it'd be fun to go through some of the compliance programs, and it actually might show up in your exam. They might ask you about some of these programs. So we'll just go down the list. So the first one here is the Criminal Justice Information Services, the CJIS. So this is any U.S. state or local agency that wants to access the FBI's CJIS database is required to adhere to this security policy. So that's their compliance program. Then you have the Cloud Security Alliance STAR certification. This is an independent third-party assessment of a cloud provider's security posture. Then you have General Data Protection Regulation, the GDPR. So a European privacy law imposes new rules on companies, government agencies, nonprofits, and other orgs that offer goods and services to people in the EU or collect and analyze data tied to EU residents. So if you're dealing with data in the EU, you got to care about the GDPR. You have EU model clauses, so contractual guarantees around transfers of personal data outside the EU. Then you have HIPAA. So this is the one that you're going to want to remember. This is the Health Insurance Portability and Accountability Act. So for U.S. federal law that regulates patient-protected health information, whenever you're dealing with hospital stuff, you're dealing with HIPAA. Then you have ISO 27018. So this is an international standard, and it is the code of practice, covering the processing of personal information by cloud service providers. That's a good one to remember. Then we have IDA. So this is a multi-tier cloud security. Singapore IDA Singapore is the organization, but this one is called MTCS. So Operational Singapore Security Management Standard, a common standard that cloud service providers can apply to address customer concerns about the security and confidentiality of data in the cloud and impact on businesses of using cloud services. Not one you have to remember, but interesting to know. This one you want to remember: Service Organization Controls, SOC 1, 2, and 3, independent third-party examination reports that demonstrate how the company achieves key compliance controls and objectives. Yeah, I know there's a lot. Sorry. Then we have the National Institute of Standards Technology, NIST Cybersecurity Framework, CSF. You definitely want to know this one. It's a voluntary framework that consists of standard guidelines and best practices to manage cybersecurity-related risks. Then you have the UK government G-Cloud. So that's cloud computing certification for services used by government entities in the UK. And the last one is FIPS. And we'll be talking about FIPS again in this course here. So this is a U.S. and Canadian government standard that specifies the security requirements for cryptographic modules that protect sensitive information. So there you go. That's compliance programs. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Active Directory. So Azure Active Directory, abbreviated to AD, is Microsoft's cloud-based identity and access management service, which helps your employees sign in and access resources. If you work for a larger company and they use Microsoft products, they're probably using Active Directory, and you're already familiar with this. But if you're not, let's learn up on this, because this is a super important service to the Azure and Microsoft ecosystem. So Azure Directory would work with external resources. So it would maybe give you access to your Office 365, to the Azure portal, which is what we're using it for, to different types of SaaS applications. It could also grant us access to internal resources. So if you have applications running within your network, or maybe you're using Azure Active Directory to gain access to actual workstations on premise, so actual workstations. With Azure Active Directory, you can implement single sign-on, and Azure Active Directory comes in 4 editions. So we have free, which provides MFA, SSO, basic security, and usage reports, user management. Then we have the next level up, Office 365. And by the way, each version up has the features prior to it. So with Office 365 apps, you get company branding, SLA, to sync between on-prem and cloud, which is really nice. For Premium 1, you get hybrid architecture, advanced group access, conditional access. And then Premium 2, you have identity protection and identity governance. But if I didn't make it clear, Active Directory is what you use to help your employees sign in and access resources. That is what it does. It controls access to resources. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at multi-factor authentication. So what is MFA? So MFA is a security control where after you fill in your username, or maybe it's your email, and password into a login portal, so this login portal could be the Azure portal, this could be you logging into Facebook. The idea is that you have to use a second device, such as a phone, to confirm that it's you logging in. And so why do we use MFA? Well, MFA protects against people who have stolen your password, because they might have your password, but they don't have your phone or whatever device that you're using for MFA. So MFA is an option most cloud providers have. And just as I said before, most social media websites have it. So Facebook, Twitter, they all have it. So just to give you a visual example, we have a form where I'm entering my email and password. Then we have a phone, which is our MFA in this case, and then we get authorization. So in the first case, that is one factor, right? So if we didn't have to use a phone or another device, that'd be considered one factor. And then multi-factor or two-factor authentication would be the addition of another device to confirm that it's you. And pretty much what's common is to use your phone and to install an app on your phone. And then what that phone will do is it will give you a random number that expires like every, 10 seconds. You have to enter that in with your username and password, or as the second step, and then you gain access to Azure portal. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Security Center. So Azure Security Center is a unified infrastructure security management system. It strengthens the security posture of your data centers and provides advanced threat protection across your hybrid workloads in the cloud. That sounds really fancy, but let's take a look at what that is. So that's what it is down below. It's a bunch of graphs, and it's going to tell you if you are compliant with particular policies. It'll tell you about your security hygiene, all sorts of security stuff, so you have a good visual about your security within Azure. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at Key Vault. So Azure Key Vault helps you safeguard cryptographic keys and other secrets used by cloud apps and services. And so within Key Vault, it has a bunch of functionality in it. So one thing it can do is manage your secrets. So store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. It also has key management. So it can create and control encryption keys used to encrypt your data. Then we have certificate management, so easily provision, manage, and deploy public and private SSL certificates for use with Azure and internal connected resources. And then it also is a hardware security module, so secrets and keys can be protected either by software or FIPS 142 or 140-2 level 2 validated HSM. And I told you that we would be talking about FIPS again, and we are right now. So to understand HSM, the last thing we're talking about, which stands for Hardware Security Module, it's a piece of hardware designed to store your encryption keys. And it literally looks like something like that. So Azure would have bought one of these or tons of these, and that is what is storing your cryptographic keys. And this piece of hardware is special because when you store keys on it, they're stored in memory, meaning that they're not written to disk. If that thing shuts down, the keys are gone and nobody can steal your data. It's just a security measure. And that security measure has to do with FIPS. Okay, so FIPS 140-2 is a US and Canadian government standard that specifies the security requirements for cryptographic modules to protect sensitive information. So for HSMs that are multi-tenant, they're generally going to be 140-2 compliant. Multi-tenant meaning that that there's more than one customer that is using that piece of hardware, but they're virtually isolated from each other. And then if you have a single tenant HSM, they're generally going to be FIPS 140-3 compliant. So a single customer on a dedicated HSM. It's better to be FIPS 140-3 compliant, but FIPS 140-2 is pretty good for most people. So there you go. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure DDoS protection. So before we talk about DDoS protection, let's talk about what DDoS is, and that stands for Distributed Denial of Service Attack. This is a malicious attack to disrupt the normal traffic by flooding a website with large amounts of fake traffic. So to get this better visualized, imagine there is somebody that doesn't like you and you have your servers and they want to attack you and they want to stop your server from running. So what they can do is they can send a remote commands to a bunch of computers that they control. And these could also be in a cloud service provider or their own data center and from a foreign country. And what they'll do is they will send thousands upon thousands of fake requests to your servers. So they'll have packets that they're sending to you with IP addresses. All those IP addresses are made up, so they're just fake traffic, and then they will flood you with so much traffic that your servers are going to crash, the network's going to crash, you're not going to be able to do anything. But the great thing is that the majority of cloud service providers, including Azure, have built-in DDoS protection. So just by using a cloud service provider, you're going to have a certain level of protection against DDoS attacks. And to talk about the different levels, Azure offers 2 tiers of DDoS protection. So DDoS protection basic is free. It's already turned on. It protects all of Azure's global network. So if you are using Azure, you already get DDoS protection. If you need something more advanced because the attacks are extremely more complex and you need more visibility and you need professional support, there's the DDoS protection standard plan. So that starts at $2,944. You might say that's high, but trust me, I've experienced DDoSing. And when you are DDoS, you're willing to pay that amount and it works right away. You'd get metrics, alerts, reporting. You'd get a DDoS expert so that you can talk to, or a team that you can talk to, and they'd have a guarantee of application cost protection, so SLA. So if they couldn't prevent the attack and you lost the cost of money, they're going to give you credits or help you out, okay? So that is DDoS protection for Azure. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Firewall, which is a managed cloud-based network security service that protects your Azure virtual network resources. So the way it works is you're going to set up a VNet, which is a virtual network, and you're going to attach that firewall, and you're going to use it as a point of entry for all your traffic. And then what you're going to do is you're going to have spoke VNets. So when I say spoke, I just mean other virtual networks that you've created that are intermediate to your traffic. So the traffic's going to pass through that VNet into those other ones, and our VNet with the firewall is going to decide what traffic's allowed to flow through and what's not to which other VNets that have specific virtual machines so that we get protection. But let's talk about some of the features of the Azure Firewall. So the first thing is you essentially create, enforce, it essentially creates, enforce, and logs application network connectivity policies across subscriptions and virtual networks. So subscriptions meaning multiple accounts. Uses a static public IP address for your virtual network resources, allowing outside firewalls to identify traffic originating from your virtual network. That's very useful. High availability is built in at no additional cost, so you don't have to create load balancers and do all that work yourself. You can configure it during deployment to span multiple AZs so that it has high availability. There's no additional cost for a firewall deployed in an availability zone. There's an additional cost for inbound and outbound data transfers associated with AZs, which is typical. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Information Protection, also known as AIP. And what this does is it protects sensitive information such as your emails or documents with encryption, and it restricts access based on rights, and it's integrated directly into Office apps. So if you're using PowerPoint or Word or Exchange or any of the Microsoft 360 suite, what you're going to have is this button called Protect, and you can drop it down and you can change the access controls, the privacy controls of your data. And this is really important if you are a larger corporation and this kind of stuff really matters to you. So that is Azure Information Protection. Just think of that button that you click and then you have those security controls. Hey, this is Andrew Brown from Exam Pro, and we were looking at Azure Application Gateway. So I believe we talked about Application Gateway earlier, and it is a load balancer. Specifically, it's an application load balancer. So it operates on layer 7, so it's dealing with HTTP requests. And because it's dealing with HTTP requests, it can actually understand the nature of a request, and you can create rules to route traffic to other places. Another really great feature of Azure Application Gateway is you can attach a web application firewall, and it will protect on the layer 7. So you can set up rules, just as you are setting up routing rules, you can set up security rules about what should be able to flow in and out of this load balancer. To give you a visual down below, you have the internet, you have your application gateway, and you can optionally attach your WAF to it. And as traffic flows through it, you could create some rules. So let's say you had a server that served up all your JavaScript assets and a server that served up all your images. You could make a rule that's saying when the path matches this, only send it to this server, and when the path matches that, only send it to that server. Okay, so there you go. That's Azure Application Gateway. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Advanced Threat Protection, also known as ATP. And so before we talk about this service, let's talk about what is IDS and IPS. I know there's a lot of acronyms being thrown at you today. So IDS stands for Intrusion Detection System, and IPS stands for Intrusion Protection System. And what that is, it's a piece of technology that monitors a network or systems for malicious activity or policy violations. And so the difference between an IDP and IDS and an IPS is an IDS detects and an IPS protects, so it actually takes action in the latter. Now, I'm not sure if advanced threat protection is just an IDS or an IPS, but it doesn't hurt to call it in the same category. It's not a big deal. So Azure Advanced Threat Protection, ATP, is a cloud-based security solution that leverages your on-premise Active Directory signals to identify, detect, and investigate advanced threats, compromised identities, and malicious inside actions directed at your organization. So there you go. That's what it does. Hey, this is Andrew Brown from Exam Pro, and we were looking at the Microsoft Security Development Lifecycle, also known as SDL, or some people might call it MSDL. So SDL is an industry-leading security assurance process, and it's a Microsoft-wide initiative and a mandatory policy since 2004. So that means Microsoft uses it because they made it. The SDL has played a critical role in embedding security and privacy in Microsoft software and culture. So building security into each SDL phase of the development lifecycle helps you catch issues earlier, and it helps you reduce your development costs. So it's talking about these phases. These are the phases for it. So you have training, requirements, design, implementation, verification, release, response. If you wanted to implement this yourself, I bet they have a big white paper on it, like a PDF you can read through, but it's just a business process. And it's just saying the sooner we implement stuff into our pipeline in terms of development, the sooner we can reduce security risks. And that is actually called pushing left, because the farther left you start implementing security, the earlier on, the better your security will be in your entire pipeline. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at policies. So an Azure policy is a service that you can use to create, assign, and manage policies. A policy allows you to enforce or control the properties of a resource. An Azure policy evaluates resources in Azure by comparing the properties of those resources to business rules. And these business rules described in JSON format are known as policy definitions. So if it's not clear just yet, do not worry. We're going to be looking at policy definitions very soon, but just understand what Azure policies do. They're used to create, assign, manage policies, and enforce and control properties of your resources. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Role-Based Access Controls, RBAC. So this isn't a service in particular, but it's more of a concept of how all the components of gaining access to resources works. So Azure Role-Based Access Control helps you manage who has access to resources, what they can do with those resources, and what areas they have access to. So you have role assignments, and this is the way you control access to resources. So a role assignment consists of three elements. You have the security principal, the role definition, and the scope. So talking about the security principal first, this represents the identity requesting access to the Azure resource. So this is who wants to have access. You could have a user, which is an individual profile in your Azure Active Directory. You could have a group of users in your Azure Active Directory. You could have a service principal. So this is a security identity used by applications or services to access specific Azure resources. This is when a service wants access. And you have managed identity. This is identity in Azure Active Directory that is automatically managed by Azure. That one's a bit more harder to describe, but that's not that important for the exam. Then the last component here is scope. So this is the set of resources that the set of resources that the role assignment is going to be granted access to. So scope access controls at the management, subscription, or resource group level. So to explain that, the idea that I'm trying to get here is that you have resources down below, right? And that is what you want to gain access to. But you can set scope at the management group level. You can set scope at the subscriptions level. You can set scope at the resource groups levels. So just to talk about those three, management group is when you're managing a bunch of accounts. Subscription is an individual account, and resource groups is a grouping of resources. So wherever you want to apply that scope, you can choose any one of those three there. Now looking at a role definition. So a role definition is a collection of permissions. And so remember when we were talking about a policy earlier, this is kind of where that comes in because policies are permissions. A role definition lists the operations that can be performed, such as the read, write, and delete. Roles can be high level like owner or specific like a virtual machine reader. And just to give you an example, so Azure has built-in roles and you can define your own custom roles, but I think you have to pay more to be able to do custom roles because that's through Azure Active Directory. But the built-in roles you need to know, which is owner, contributor, reader, and user access administrator. These are the four fundamental built-in roles. Now, look at the graphic there. We have the green and the red. So for an owner, you can read, you can grant, you can create, update, and delete resources. You can do everything. As a contributor, all you can do is read, create, update, and delete. You can't grant access. You can't allow other users to gain access to your resources. Then you have a reader. So a reader, as the name implies, can only read resources. They can't create up and delete. They can't grant access to other users. And then a user access administrator only grants. So their job is to give access to other resources, but they can't do anything themselves. So there you go. That is role-based access controls. Hey, this is Andrew Brown from Exam Pro, and we are looking at lock resources. So as an admin, you may need to lock a subscription, resource group, or resource to prevent other users from accidentally letting other users delete or modify critical resources. So in the Azure portal, you can set the following lock levels. You can set it to be cannot delete. And so in the Azure portal, this would just be called delete. And this will allow authorized users can still read and modify a resource, but they cannot delete the resource. Then you have read only, and in the Azure portal, it's going to be read -only. And this is so that authorized users can read a resource, but they can't delete or update a resource. Hey, this is Andrew Brown from Exam Pro, and let's look at Azure Management Groups. So Azure Management Groups is a way of managing multiple subscriptions. And when you hear the word subscriptions in Azure, just think accounts, because that's an easier way to think about it, into a hierarchical structure. So each directory is given a single top-level management group called the root management group. All subscriptions within a management group automatically inherit the conditions applied to the management group. And so this is a graphical representation. So at the top, you have your root management group, and then you can create management groups underneath. So human resources, IT, marketing, production, developers, whatever you want. And underneath, you have those individual subscriptions. Again, just think of them like an account. So that is Azure Management Groups. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Monitor. So Azure Monitor is a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premise environment. So if you were to go into Azure Monitor on the left-hand side, you'd see all these options: so activity log, alerts, metrics, logs, service health, etc. And so that's what Azure Monitor is. It's like an umbrella for a bunch of services underneath. And so here's an example of a bunch of information in the form of a dashboard about monitoring and analytics. So with Azure Monitor, you can create a visual dashboard, as we can see here. You can create smart alerts, you can create automated actions, and you can collect logs so that you have log monitoring. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Service Health. So this is about information about current and upcoming issues such as service impacting events, planned maintenance, and other changes that may affect your availability. So going down the list, we have Azure Status, which informs you of service outages in Azure. Azure Service Health is a personalized view of the health of the Azure service and regions you're using. And then Azure Resource Health is information about the health of the individual cloud resources, such as your VM. So if you're ever wondering the state of your health, you can use Azure Service Health. And if you noticed, it was an option under Azure Monitor. So if you're looking for it, that's where you go to find it. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Advisor. So Azure Advisor is a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. The Advisor dashboard displays personalized recommendations for all your subscriptions for the following 5 categories: high availability, security, performance, cost, and operational excellence. And since we are in the security category, that's what we mostly care about is security, but it would also be important for the pricing section there as well. So the first one we're going to look at is actually the Azure Advisor recommendation for costs. So here you can see that it's telling you where the most impact can occur, and it'll even tell you how much money you can save if you follow its recommendations. Then you have security, and so here it has 21 recommendations. If we were to click into it, it would tell you what kind of things that you could improve in your system to improve your security. So there you go, that's Azure Advisor. Hey, this is Andrew Brown from Exam Pro, and we are looking at SLAs for Azure. So SLA stands for Service Level Agreement, and this describes Azure's commitment for uptime and connectivity. That means, like, if you have a web server, Azure's going to say, yeah, we guarantee 99.9% of the time it's going to remain running throughout the year. It's not going to go down. So that's kind of the idea behind an SLA. For Azure, SLAs are individualized per Azure service, so they don't have broad SLAs. You're going to have to investigate each service to figure out what the commitment of Azure is for that service. And the way we describe these SLAs in terms of uptime and connectivity is through performance targets. Now, a performance target is just a representation in the form of a percentage. So if somebody were to say to you, this service is 99% likely of not failing, that's called 2 nines. And then you have the 3 nines, and then you have 5 nines, and then you have 9 nines. And the higher this number goes up, the more reliable, the better coverage this SLA is going to give you. So you want something that has a higher number of nines. And it's not always just nines. It could be 99.95%. But just understand that when someone says 9 nines, they're talking about that last value there. And it is like one of the highest guarantees an SLA can give. I can't remember if there's like 11 nines. There might be 11 nines. But generally 9 nines is the upper limit. And just to mention is that for Azure, if you are using the free tier or shared tiers, you do not get SLA because they just do not provide support for those because you're consuming everything for free. So you have to be paying to get the advantage of that SLA guarantee. So I did say that the SLAs are service specific. And so if you want to actually go investigate, all you got to do is type in Azure SLA into Google, and you should be able to make your way to this page. And what we can do is we can click into any of these here. So if I go to database and we choose Cosmos DB, and we just expand our information here, we get tons of information about their SLAs. And then our performance targets are down here. So we have this for availability. This is for read availability. So they have a lot of information. As I said, it's for basically any service, anything you want, just click into it, and they have all that SLA information. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at service credits for Azure. So a service credit is when a customer would get a discount on their Azure bill as compensation for an underperforming Azure product or service based on the SLA. So those guarantees that Azure gives, if they don't meet those guarantees, then they owe you money. And the way they do it is through credits, right? So credits is just like virtual money. I actually don't know what a service credit is worth, but I just know that if they do not meet those SLAs, they're going to back it and give you your money back in some sense. So just an example here: if we have Azure Virtual Machine, remember a virtual machine is a server. If you had a monthly uptime percentage of 99.9, so if it was under that, then you'd get a service credit of 10%. If it was under 99, then you get a service credit of 25%. And if it was under 95, you get a service credit of 100%. So I guess what that means is maybe it's the cost of what you spent. But anyway, I'm not exactly sure. But I would take a guess that if let's say the uptime was under 95% and they're going to give you a service credit of 100%, maybe it's 100% of your resources given back to you. So if you spend $100, you get that $100 back. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at composite SLAs. So we had said earlier that different services have different SLAs. And the problem with that is that when you have different services, different SLAs, it's kind of hard to understand what the actual guarantee is when you use them in combination. And so composite SLAs is just a way of understanding what the actual SLA guarantee underneath is for the performance target. So imagine you have a web application, and that web application uses an SQL database. So the web app has a guarantee of 99.95%, because maybe that's the performance target for the virtual machine, and then the SQL database is 99.99%. So what is it? Is it 99.95% or is it 4 nines? We don't know. So if we had to calculate that for the SLA with the web app and SQL database, that would come out to 99.94%. Don't ask me on the math. That is the example that we are given, but just understand that that's what it would come out to. It would come out to 99.94%. And so you'd have an overall reduction of the SLA, whereas the SQL database would have 99.9%. So how could we improve our SLA and consider that in our design so we get the SLA that we want? And so what you can do is you can add in fallback systems that will improve the overall SLA. And if you logically think about it, it makes sense why that would work. So imagine you have that SQL database and it goes down. But if you had a queue, and that queue was saving all the transaction attempts that the web app was trying to write to the database and saved in the queue, it wouldn't matter if the database went down, because once the database went back up, all those transactions would be there, and then those transactions would then complete. And so by using the queue, which has a 99.9% uptime, based on the math down below, again, don't ask me how the math works, but the outcome would be an SLA of 99.95%. And so that's an improvement over 99.94%. So that is composite SLAs, and there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at the TCO calculator for Azure. So if you remember earlier in the course, we talked about the total cost of ownership. That's what TCO stands for. It's about showing an enterprise that operates on-premise how much money they would save if they moved onto cloud, onto Azure. So that's what the TCO calculator does. It estimates the cost savings you can realize by migrating your workloads to Azure. So what it can do is it can generate out a detailed report and export as a PDF to send to your decision makers. Now you have to input all the information in, but it's going to help you convince your boss, convince the executive level that it's time to move over to the cloud, because they'll be saving tons and tons of money. And so if you want to use that calculator, you just got to go to azure.microsoft.com/pricing/calculator, and it's going to give you an idea of how much you'll save. And now this is only a little bit of what it generates out, because it's a very detailed report. But in this example, it would compare on-premise to the cost savings of Azure. And in this case, this person would be saving $130,000 over 5 years. And it's going to vary on use case. But yeah, that is the TCO calculator. So I just wanted to quickly show you the TCO calculator in action. If you want to find it yourself, just type in Azure TCO calculator into Google, and you should be able to find your way here. So what I've done here is I've defined my workload. So in my workflow, I've defined some servers. So we have some Linux servers. We have 10 of them, 4 processes, 4 cores, 8 gigabytes of RAM. And then here I've added 4 servers that are databases running Postgres. Then I added some HDD drives. So I said 3 terabytes, 2 terabytes backup, etc. And then I defined some network bandwidth. So going on to the next step, we're going to adjust our assumptions. This helps us to make it even more accurate, the estimate. So we can choose our currency, some other additional features we might want to consider where we might save money, like using Azure Hybrid Benefit. And then down below, we can tweak some of our costs that we do know about for our on-prem. So there's a lot here to tweak it to make it more accurate. And then if we go to next, we're going to get our savings here. So just wait a moment. And so over a 5-year period, we should save $666.158. And you can drop it down if you want to do 1 year. We'll go to 1 year. So here it says $381. And we have a lot of graphics here, as you can see. And then down below, you should be able to download it. So you can just go ahead and download the results there. And that is the TCO calculator. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Azure Marketplace. So the Azure Marketplace is a place where there are apps and services made available to you by third-party publishers to quickly get started on Azure. And so the apps available, the apps and services that can be available could be free, they could be free trial, they could be pay-as-you-go, or they could be bring your own license. So just an example of what that looks like, if you were logged into the Azure portal and you searched for Marketplace, what you could do here is you could type in a variety of things. So like here I'm typing in WordPress, and here I have a bunch of WordPresses that are provided by third-party publishers that have been vetted by Azure. And again, they could cost money, they could have a free trial, they could be 100% free, but whatever you need, it's generally in the marketplace. And it's a great place to go check out. So just be aware of that. So I just wanted to quickly show you the Azure Marketplace. So you'd have to have an account to actually see it, but we do show you that in this course. But anyway, I'm just gonna go up here to the top and type in Marketplace. And this will pull up the marketplace. And here you can see we have a huge amount of categories of things that we can launch. So whatever we need, and I think I showed before WordPress, but we'll type that in there. So we'll enter in WordPress. And there's all these servers, so you can click into there. It might have plans associated with it if there's any price, but you just go ahead and hit create, and then that would start the process of creating a virtual machine, and you'd go through that, and you'd subscribe to whatever the underlying cost would be. But you can see there's just tons of stuff in here. So, and you can sort by price, you can sort by operating system. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure support plans. And so we have 4 support plans. We have Basic, Developer, Standard, and Professional Direct. Technically, we have 5 if we count Enterprise. I don't think it's going to be on the exam, and there's not a lot of information around it because you got to call sales to find out those Enterprise price and support. So let's just go through the difference between these things because it's definitely important for your exam. So we're looking at the basic support plan, and everybody gets the basic support plan when you sign up. You get email support only for billing and account. So if you have any questions about your bills or questions about your account, you can get answers from support. Now, for Developer Standard and Professional Direct, you get tech support, and you get email tech support for all levels. And generally, if we're talking just for developer, they're only going to reply during the business hours. But if you had Standard or Professional Direct, they have people answering emails 24/7 around the clock. I think the general response time for email support, no matter what level it is about 24 hours. But it's just going to vary. So I would say that if you need something that is more urgent, then you're going to want that phone support. And so phone support is for Standard and Professional Direct, and that's 24/7. So if it's a Saturday and it's 9 p.m. and you need to call support, you can do that. And sometimes you only have to wait 10 to 15 minutes. I'm not sure if Azure has chat, but it's very common for cloud service providers to provide both chat and phone support, and you wait 10 to 15 minutes and you get access there. Now, for third-party support, if you are using technologies like Ruby on Rails, Spring, Django, those things aren't really part of Azure. They're third-party software that you're using to build your web application, and Azure is going to try to do their best effort to support you, even though it's not what they've built and that's not what they have to do, but they're going to do their best effort for Developer Standard and Professional Direct. So that is an advantage for paying for support. Now, in terms of response times, when you open up a ticket, you can say the severity of your ticket, and that's going to determine how fast they respond if you need the response. So if there's a ticket and you say that it has minimal business impact, so maybe it's like general questions or something, that's going to be considered a severity C. And for Developer and Standard, they're going to respond within 8 hours or less. For Professional Direct, you're going to get that in 4 hours or less. So again, that's just general questions. Now, if you have something that it's going to have a moderate business impact, then the time is going to be a lot faster. They call that severity B. So it's going to be less than 4 hours. And then for professional direct, it's going to be less than 2 hours. And so this would be if your production system was compromised, but it's not taking your business down. Now, if you have a critical business impact, that means your web app is 100% down and you are losing money by the minute. You open up a ticket called critical business impact, which is severity C. Actually, it should be severity A. It's just a spelling mistake there. But they would respond within an hour or less. So what I find is that there's even though they say an hour or less, it's not always the case, but that's generally how fast they're going to respond. Now, for other services, you get Azure Advisor, the health status, the community support, and Azure documentation, and all these support plans. The only reason we're mentioning this here, and they mention it on their support page, but they're just trying to say, hey, just be aware that you have these additional support tools that you can use at any given time that are self-serve. So the community support and the Azure documents. Now, if you need some general guidance on your architecture, you're going to get that with developer and standard. So you can definitely ask questions there. If you are using professional direct, you actually get access to a team, and in that team, there's a pool of people that you may get when you talk to them, where they'll give you a guidance, and they call those operational support and proactive guidance by Pro Direct delivery managers. So professional direct is called Pro Direct, and so they have delivery managers. I don't know if that means that they're developers, but the point is that they're going to put some extra effort to help you there. And then also you can actually access webinars led by Azure engineers. So that's really cool as well if you pay for the professional direct. So just going through all the support plans here for the pricing. So basic is free. And when you sign up, if you don't choose the plan, you are using basic. And then for developer, it's $29 per month USD. For standard, it's $100 USD per month. And for professional direct, it's $1,000 USD per month. So there you go. That is the Azure support plans. So I just wanted to show you how to get to this support plan page in case you want to investigate a bit further. But pretty much my graphic sums up everything that is included in the support plans. So if you want to find this, you just go to Azure, just type into Google Azure support plans, and you should be able to make your way here. You'll notice we have the 4 plans, and then there's enterprise support. And if we go here, there's more information on this. But again, you'll have to call support to find out the actual price and offerings there. But yeah, just take a look here and see if there's anything I missed, but I'm pretty sure I have everything you need in the main graphic from the slide prior. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Hybrid Benefit. So many customers have invested already in Windows Server's licenses, and they want to repurpose their investment on Azure. This happens because enterprises have been working with Microsoft servers even before Azure existed, or they were on-premise originally, and so they wanted to use the software, so they purchased the licenses, but now they're ready to move on to Azure. And so since they've already got a special deal with Microsoft because they purchased those licenses, they want to keep those deals and bring them to the cloud. So that's where the Azure Hybrid Benefit comes into play, also abbreviated as HUB. Sometimes it's called Azure Hybrid Use Benefit in Microsoft documentation, but for some reason Azure, they just dropped the word use, but the abbreviation is HUB. So this gives customers the right to use these licenses for virtual machines on Azure. And so such types of virtual machines would be Windows servers or SQL servers. And I would imagine this would probably happen with a lift and shift, which I think we described somewhere in this course. So HUB can be turned on and off at any time for existing virtual machines, and HUB can be applied at deployment time for new VMs. And I just wrote bring your own license down here just because we are talking about licensing, and I just want to get you more exposure to that term, bring your own license, BYOL. And so that just means that someone's purchased a license and they want to apply it, they want to bring it onto Azure. So there you go, that is Azure Hybrid Benefit. So I just wanted to quickly show you this page here, which is the Azure Hybrid Benefit page. If you were to type into Google Azure Hybrid Benefit, you definitely make your way here. What I wanted to show you is that they actually have this nice little calculator down below. So if you do have licenses and you're bringing them over and you want to run workloads on Azure, you can fill this stuff out and it'll give you an idea of what you might save. So I just wanted to make you aware of that. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure subscription. So an Azure subscription, I would describe as the equivalent of saying my Azure account. I don't know why they use the term subscription, because to me it's just confusing, but I always just try to reinforce that it's just your account. And there are 4 tiers of Azure subscriptions. The first is the free subscription. So when you first sign up, this is the account that subscription you're going to have. You have to provide a credit card to complete the process. You're going to get 200 USD credits free for 30 days, and certain Azure products will be free for 12 months. Now, the whole point of this free subscription is to help you avoid charges, and there are some limitations. I remember when I was trying to add another user, I couldn't grant them access, so there was definitely some limitations here to prevent you from being charged. But it's not a complete sandbox, so it is possible to get charged in this account if you start using things outside the free tier, or if you burn through your credits. So just be careful there. And then once you are ready to switch or to upgrade and unlock everything, then you can switch to pay-as-you-go subscription, also abbreviated to PAYG. Some people might call that on demand. And so for this, you still need a credit card required, but since you've already entered it in the free subscription stage, no problem here. And you're going to be charged at the end of the month based on consumed cloud resources. Then you have an enterprise agreement. So if you are an enterprise, you can make a deal with Azure and agree to receive a discounted price for licenses and cloud service, but I bet you're paying a lot of money, like compared to a normal person, but the deal is worth it for you. So just be aware, if you're an enterprise, go talk to Azure. They want to make a deal. And the last is the student subscription. So with the student subscription, you do not require a credit card. You get $100 USD credits for 12 months, but it requires a valid student email. So there is a bit of a vetting process there. So you definitely have to be in school to get that, but it is a very nice option to have. So there you go. That is the Azure subscription models. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Pricing Calculator. So configure and estimate the cost of Azure products. You don't have to sign in to use this tool, and what you can do is download an Excel spreadsheet and share that those costs with your boss. So to get there, you go to azure.microsoft.com/pricing/calculator. And from there, you can go in here and you can fill out different things. So there's a bunch of different categories. The most common one would probably be a virtual machine. So you go in there and you say what region it's going to launch in, what OS, and all the types of configuration. And it's going to give you an estimated cost. So this one down below is an upfront cost of $0 with a monthly cost of $152.62. So if you're not sure how to make sense of all the pricing, go here and play around and you will get a clear picture of what you're going to spend on Azure. So I just wanted to show you the pricing calculator. So if you just went to Google and typed in Azure pricing calculator, you should be able to make your way to this page. And so down below, we have a bunch of products. We also have example scenarios, which is very nice to see here. So let's say we wanted a CI/CD pipeline here, and we said add to estimate. We could get that information for all these components. I'm just going to go to single products because it's a bit easier to view. So let's say we want to determine our costs for storage. So let's just go to storage here, and we will try storage accounts. And then down below, we've now added storage. And so we can enter some information to try to determine our costs. So we could do blob, file storage, table storage. I'm going to go with file storage. Actually, no, I'm going to go with blob. It's just easier to calculate. And so we're going to have the performance tier to premium, redundancy LRS, and we're going to be East West. And so if we had 1,000 gigabytes, I guess it's a terabyte, that's $150. If we had X amount of write operations, X amount of list and create container operations, read operations, and here we'd have $150 as a monthly cost. So here you just have to tweak it based on your consumptions. And then generally they'll show you like purchase options. But really, this just means like go sign up for an Azure account. But I just wanted to show you what that looks like, and just so that you know that you can go explore any cost and try to calculate something before you use it. Hey, this is Andrew Brown from Exam Pro, and we are looking at Azure Cost Management. And so this service allows you to perform cost analysis so you can visualize the spending of your Azure cloud resources, but you can also create a budget under the service. So when you set a budget, you're going to define a threshold, and you're going to be alerted when you're approaching or you've exceeded that threshold. And so just to give you a visual representation there, that is for the cost analysis. So you can see you get beautiful graphs and you can drill down and filter that stuff out to really understand how you are spending stuff on Azure. So definitely check it out, and there you go. Hey, this is Andrew Brown from Exam Pro. I'm going to show you how to book your exam for the AZ900. So what I want you to do is type in Pearson VUE Azure or Pearson VUE Microsoft into Google, and you should make your way to this page. And then what you're going to want to do is on the right-hand side, go ahead there and click Login. Then it's going to ask what certification you want. I'm going to type in the AZ900. And so there is the certification there. Then we're going to see this page that's going to show us some intermediate information about the certification. What we're going to do is go ahead and schedule with Pearson VUE. Now there is with Certiport, but that's if you're a student or an instructor. We are neither, so we are going to be choosing the Pearson VUE mode. There's this drop down here that literally does nothing. I don't know why they have it here. I thought maybe it would change the price. Maybe it would change the availability if based on where you are, but we'll go ahead there and hit schedule with Pearson VUE. What's going to do is ask us to log into our Microsoft account. Mine is called Azure at exampro.co. It's the same account I created when I created my Azure account. And then I'm just going to put my password in there. We'll hit sign in. And then the next step is it's going to ask me to fill in my certification profile. So this is all personal information relating to me. And notice that you have to enter it exactly as your government issued identification so you can book the exam. So I'm going to fill this in and proceed to the next step, and I'll see you there. All right, so we're on to the next step here. And so we finished my profile step. We're on to exam discounts. I'm not a Microsoft employee. I didn't attend an event, so I'm not getting any cool discounts here. So we're just going to have to go ahead and proceed to Pearson VUE to schedule our exam. So just wait here a moment. And so now that we're on to here, it's going to ask, how do you want to take the exam at a local test center, at my home office, or private access cloud? I'm going to show you how to do it at a local test center. We might not have any options here, but we'll give it a go. And we're going to choose our language. English is the case here. And it's going to say the price and etc. We'll go to next. And so what it's going to do is it's going to show me locations that are nearby to me. So down below you have a graph and you have some stuff there. So we'll just take a look here. And so what I can do is I can click on a location. So I'm just going to choose the Mississauga Center. That one's pretty good. So I'm going to go ahead and checkbox that. And we're going to have to select at least 3 test centers here. So I'm going to choose this one and that one. And we'll proceed to next. And so now we have some options here to schedule. I want the Mississauga one. We'll have to go back to this one here. And then we will choose our time. And so from there, all we have to do is add to order, pay, and there you go. So that's all it takes to book your exam. So good luck on your exam.